got we've got to tweak a few things here, and we can make ourselves known. I think I've got everything right here. What do we need? What am I missing? I'm missing something and I can't see what it is. Oh yeah, here we go. That's what you need. Now we should be good to go. I don't need that.
Oh, we've got a rumpus in the Discord.
Got a rumpus in the Discord.
Yeah, you know how to get onto the stream, rumpus.
He can hear me through you. I mean he can, the other way around. Oh, what have I got? What got closed captions going on me live stream over there? Okay, I wonder if Rumpus knows how to get to the special place.
Hello, so I just connected myself up there. I haven't been listening, I'm afraid, so I've just got myself sorted.
This is only technology, and I'm the dumbest person here, and I can figure this out, so it's not that hard.
Oh well, I had to. I have a strange connection between my my microphone. I'm using wireless things, and I have to switch everything on, plug it all into. So you've
got to make things so complicated, people. I don't know.
Indeed.
Technology, it's so easy. It's just plug and play, isn't it, these days?
Well, not if you've got wireless microphones. It isn't. You have to plug in. I have to plug in about 4 things to get it all going. And also, I've got an annoying loudspeaker thing that switches itself off after 20 minutes if I don't use it. So I have to.
Sounds like a you problem.
Then I have to get my headphones connected, and oh dear. So before we know, and then I have to.
I got a wireless headset. Does that make it any easier for you? I've got a wireless headset, and I'm running Banana through ABS.
Oh, are you running Banana? How'd you get on with that?
It's going all right. I've no dramas.
Really? Okay.
Yeah.
You haven't. It hasn't caused.
No, I've never had any issues with my Banana.
Right. Okay.
Mm.
So do you know how to get onto the Do you know how to get onto the Zoom meeting, Rumpus?
No, I wasn't aware there was a Zoom meeting.
Yeah,
I've got Zoom. I've no idea what's going on.
Well, we're all in Zoom, and you're in Discord.
Okay, all right. So I didn't know. I wasn't aware of that. I was just told to come here by is it Cursed with a.
Yeah, that's me.
Yeah, that.
Paul.
Yeah,
that's
Paul.
Right.
That's Paul. That's Paul. Of course, it's Paul.
Paul. Right.
Yeah.
Yeah.
Right.
See, I can change my voice to Paul at any minute now.
You know me from right back in the early days.
People, it's confusing me. Yeah, Paul, indeed. Yeah, great to hear from you again. Yes. Fantastic story about your split personality. I think that's fantastic. Doing sort of
split personality.
Well, you got quite split job personality. I think that's great. So one moment you're getting down and dirty and sort of engaging with the earth, basically, and then next moment you're doing highly theoretical quantum stuff.
Yeah, it's great. It's good.
That's a good balance, that, isn't it? Right, let's get.
It is. I'm really enjoying it.
Jolly good. Because you were teaching before, weren't you?
Yes, but I gave that up. I got out of Melbourne because I was hating it in there. Yeah. Well, I was teaching at university, so yeah.
Right.
But I got out of that because I just couldn't handle it. It was stressing me out too much, and I got out of Melbourne before all this COVID. I got out of Melbourne before all this COVID crap happened and set myself up with a nice, comfortable country lifestyle, Rumpus.
Right. Well, it's odd that because when you came back, you sort of went away for a year or something, and when you came back about you first came back, I think, on to hang out about a year ago, and I thought, my God, you got all quite aggressive and things to people. I thought you've changed personality or something. You were very much more.
No, not at all. I went down to. Well, I went down to. I was missing in action because I went down to Antarctica for 3 or 4 months. Yeah. So I've been around.
Zoom thing right. Okay. Let me get this Zoom thing sorted. So where's the link to the Zoom?
In the special place. Just scroll down in Discord to from where you are now. You'll go down to a place called the special place.
Got it.
Yeah. And you'll see the last post for the Zoom meeting link.
Okay.
And you get fined if you haven't got an avatar.
Ah, oh dear. Might be just a fine then.
You can get an avatar when you're in there. There's no hassle about that. So.
Yes, it's something I've been meaning to organise actually. Right, let's. Okay,
and you want to change your name when you get in?
No. What name have I got? Oh God.
I'll.
Okay, that's not me. That's another one of my aliases. Okay, yes, I really have to change that. No.
Okay.
Okay, so I can change my name afterwards. Okay. It should be. Right, you are. Okay, let me. So how do I rename? Okay.
Oh, back to your regular scheduled programming, and Paul's done his scientist. I have to scroll back up to the clue. How far back up? Oh, there it is. Scientist of the day is G. So G's the first word. Oh no, D. Oh Jesus, D's the second one.
Jesus, what are you talking about?
I couldn't read it. I couldn't read it properly. His first name starts with a G, and then it's got a small D, 2 letters, and then H is his last name.
Is someone live going around mowing a lawn?
Yeah, that's John.
Yeah,
John lives in Queensland.
Oh, that's John. John's doing his lawn. I'm driving around the duck farm.
Oh right.
And if you look closely to my avatar, if I can, I'll put it up. I'll show it. How can I do
I'll have to pop out
there
the
we
chat
go.
again because my chat wasn't moving.
So
Now,
how are you moving? So is this just a video you've taken just putting it as a background? This is not live. Then there's not some. We haven't got some live.
He driving around the tractor backwards.
No.
Yeah, he drives around on backwards.
No.
Is this a drone? Or
Yeah,
something?
drive around backwards.
So how good are you with your star trails, Rumpus?
It's my star trails.
Right. Okay. So look at my video.
I wasn't aware that was a subject.
Oh, this is well, we've got millions of subjects, but we'll just stick with a couple tonight. On my thumbnail video that I've got going, not many people pointed out, but you should be able to notice the flaw.
I can only see this rotating background of your on your. It is your avatar. Yes, it's a rotating star field with your Aussie flag there in front of it.
Right. So
I'm supposed to be looking at the floor in the star field, am I?
Well, it's the star trails in particular.
Well, the star trails are very tiny.
Okay. Which way are they rotating?
Well, they're rotating anti-clockwise, which obviously is something you'd expect around the North Pole.
All right, and where am I?
Yeah, they're the wrong way, aren't they?
Well, you're on the South Pole.
All right, exactly.
But I mean, this doesn't look like. I mean, it doesn't look like any. I mean, that star field doesn't look like anything I've ever seen before. So it's not.
Alan did them star trails for me, and I've been just waiting to get a star trail video to replace it. So, but I thought it was a novelty having the star trail from the Northern Hemisphere for the Australian flag ball thing. So.
Oh, one thing actually, I did actually about a year before I got involved in this wrecked thing I'm doing. I was trying to do a simultaneous observation from the Southern Hemisphere of the Southern Pole, and I don't know if you remember, but Anthony Riley was saying that if he saw that everybody in the Southern Hemisphere saw the same pole, that he would become a globe earther. So it was last year. I tried. I was on the verge. I got about 10 people from the Southern Hemisphere, but I don't think I got you or Paul. Well, I think Paul was out of commission, wasn't he? Or you two. I organised about 10 people to go ahead as a simultaneous observation, which would involve from South Africa, Perth, lots of people at the east coast of Australia, obviously, and then New Zealand, and they would do a simultaneous thing. I was organising people having the equipment and things and cameras to do a simultaneous observation. So my time would be 7 o'clock in the evening. I think it would, for most of you lot, would have been, except for the guy in New Zealand, I think about, well, Saturday, except for 3 o'clock, I think, for most people in Australia, and then I think the poor person in New Zealand would have been 5 a.m. And I was checking out all the visibility things. Anyway, so the idea was a simultaneous observation of the South Pole from many locations in the southern hemisphere to demonstrate that you were all looking at the same thing, except it was rotated. So that was a plan. So this summer, I'm hoping to do the same. I will actually execute it this time. And last summer, I didn't manage it because I got involved with all this wreck stuff. Actually, sorry, it was a year and a half ago. Yes, I planned this, and I got Where's Wally and Ruhiv was too busy ensconced, and he never seemed to come out of his house these days. I couldn't get him to come out and do an observation for me. Professor Phil, who was in Melbourne, and lots of other people anyway, about 10 of them. I was trying to organise it. So hopefully, if Paul's around and you're around,
I'm
this
around.
summer then we'll do that, and perhaps we can convert Riley to
what? You're trying to make
that's what he said.
A joke.
I dare.
Jeez. You're asking a bit much, aren't you?
Well, he said several times, and he's confirmed this. If you could show that the southern hemisphere, everyone in the southern hemisphere pointing in the same direction, could see the same star field, he would become a glober. He's made the stuff.
You're forgetting Riley's primary characteristic, though, Rumpus.
Yeah, indeed. I said. Remember, notice what I said. I said that's what he said, which is quite different from what he will do.
Yeah, exactly.
You show him any proof of something, and he'll just go off on it.
Yeah, he'll claim that something like all the 10 people have been paid, or this is why I was going to get people to show where they were. I mean, I've got a 10-point procedure for all the people making observation about showing the compass of where they're pointing, having something in the view, showing where they are, and showing with their phones where they are, and using a compass or phone showing where they're pointing. I had a whole series of things that hopefully even a flatty would have problems. Well, I must admit, they just deny reality. But hopefully, in other words, a number of things that demonstrate where you are and where you're pointing, all of you at the same time, which would make a pretty convincing case. And it was going to be, I'd say the idea was going to be about sort of a 3 or 4 hour transmission. It's going to be live, so people could, moan. So, in other words, we could demonstrate it was live as well, and so that flatties or whatever could come in and say, hold on, get Paul, Paul, jump up and down or something while you're pointing your camera, and then you could wave his arm or something, and then or hold a newspaper or something for that day, etc., etc. So all those sorts of things to prove that people are doing it live. So I've got quite a plan actually. Now Paul's back in action.
Is it a cunning plan?
It is a cunning plan because I've hopefully got so many things in there that to avoid it being claimed to be false in some way. Because of course, Riley projects all the time, as you say. He seems to be a compulsive liar. His first, he hasn't done this so much. His first accusation of anybody's interacting was you're lying, and that's of course because that's what he does all the time, and so he feels that's what other people are doing. So classic projection thing, and so you've got to unfortunately counter someone who's like that with hopefully a rock solid series of things to prevent them from.
I mean, who could forget that classic observer height of 32 feet? Hey, Rumpus.
Absolutely. And do you remember the photograph?
Those are the days.
Do you remember the photograph of his foot when they had a tape in the same picture? They had 100-foot tape measure going down to the bottom, and then there was his foot in there where he'd done the observation from, and then he was still maintaining it was 35 feet. Yeah.
I know.
Yes. I mean, just out. I mean, I don't accuse people of lying unless I've got absolutely rock solid evidence. But when you've got his foot, and he even admitted that this was his foot, his pink training shoe, and you could see that the tape measure, which they said it was 100 feet long, and you could see that it come to the end of its extent, and you could see where it was going down to the ground, and they were sort of looking over. I don't know who provided this picture, but anyway, so we got that, and then he kept on maintaining. And then I think his trick is to then say, oh well, that was just one of my observation points. But yes, that's the one we're interested. That's where all the photographs were taken from. That's where all the whatever it was called, Ranty's composite was taken from. And now he says, oh well, that's not where I was thinking of. Oh Jesus. So So Starfield, that's what's reminded. So hopefully this summer then I will accost you all in Aussie land, etc. And there's a guy in South Africa as well. So we've got a whole span. So there's a particular, for about a month or two, you get obviously being your winter, you actually get South Africa and New Zealand all being dark at the same time. There's only a period. I think it's only a period of an hour actually to get South Africa and New Zealand both simultaneously dark. So it's quite a tricky bit of time. You also got to make sure things like the full moon aren't in the way, and God knows what else. But yeah, it's quite so. Yeah, that's okay. Now Paul's back in action.
What? Because if there's a full moon, we'll take crazy measurements or something.
Well, it just gets in the way of seeing stuff. I mean,
yeah, I know.
Starfield, yeah, and perhaps send you crazy. Yes, yes. So it's tricky, and also getting. I mean, if you look at the optical pollution, actually, people in Melbourne just haven't got a hope of being able to see very much. You've got to basically go drive about 30 miles. So part of my request to people was to get out of, any big trouble. All Aussies seem to be in the bloody big cities. I think I was actually.
I'm in a location where I get excellent dark skies.
Brilliant. Oh well, in fact, you could be a key member. Right, you could be key there because or at least you don't. Also, who's the goddamn woman on who used to appear on Brandon's all the time? Who lives in a farm in southeast Australia? Who's sort of all libertarian and all having guns and shooting people and not having vaccines and things, and she has really good skies, and she, being a flatty, was also prepared to join in on this, which was good. What's her stupid name?
You're not talking about Becky from Australia?
Not Jackie. No, it wasn't Jackie.
Not Jackie.
Paige.
Paige. That's it, Paige. She lives on a farm in southeast Australia, and she has got excellent conditions. And I was hoping to get, and there's some guy in Darwin is not so bad, but the worst was Johannesburg. One of the guys in South Africa at Johannesburg, and he's got to drive about 50 miles or something to get vaguely reasonable conditions. But I haven't got agreement from everybody to drive this far, but that's what it's going to require for some people, sort of 50-mile drive or something, which is perhaps some people might not do that, but yeah, great. If Paul's excellent, Paul, great. That's if you're in that position, that's really useful. Oh my God, we're looking into.
I only caught the tail end of FTFE's stream the other night, Rumpus, when you saw my comment. So.
All right. Right.
I didn't see the rest of the stream, and I haven't watched the rest of it yet. I should watch it, but man, I don't know how he keeps his sanity having those people on.
Right. Yes. Well, obviously. Well, he doesn't sometimes. He was having problems keeping away. Didn't he have some hallucinations or something a month or so ago? Well, also he's changed his, because he's trying to pander to the Americans. He's living on American time, which means he goes to bed at sillily late and gets up stupidly late.
Okay.
And I think that was stressing his time, his sleep patterns or something. And he had some sort of weird hallucination.
Maybe I can excuse him for saying some silly physics things then.
Yeah, well, I'm not so sure about that. I'm not sure that's the cause of his silly physics.
Like for example, would you call a laser beam a coalesced light beam, Brumpus?
Coalesced? Did you say? Did you say? Sorry, no, I would not call it coalesced. No, I would not.
Exactly. That's right.
Coherent is the word you're looking for, I think.
Ah, yes, that's the one. Yeah, exactly. You know what I'm talking about. Yeah.
Yeah, I mean, he tries, this old FTFE, but
it's just little things like that. He tries. Yeah, he tries, but sometimes he says silly things. Yeah.
He does. He gets most of it right, but I have to. I mean, every time he does one of these things, he does make at least 2 mistakes or something per thingy. But the key thing is he accepts them. He's quite good at taking on board.
Yeah, which is good. Yeah.
Yeah, and so he'll get better. So, and he has definitely. I mean, when he first started on this a couple of years ago, he was making mistakes all over the shop. But he's gradually, he's getting better and better. So, So I don't know. So am I interfering with this quiz? Am I interfering with the quiz here?
Not yet. The quiz is not yet.
No.
All right. Okay. Jolly good. Okay. So I don't know. I mean,
we've got a few other things to do first before that.
Oh, rightio. Okay. So I mean, Paul invited me on here about general relativities. I don't know if you wanted to chat about that or.
Oh, we'll probably get to that.
You're trying to do.
Yeah, we'll get to that.
Okay. Well, don't let me stop you. Whatever you're trying to do, Terry.
No, that's okay. So the scientists of the day won a Nobel Prize for pioneering the technique of using isotopes as traces to figure out biological processes in plants and animals. So has anyone got there yet?
And look back if anyone's actually got it yet. We know that his first name is George, and his middle name starts with he's George de something. I'm not sure if he's actually got the last name yet.
You're breaking up a bit, Paul. I don't know if you're aware of that.
Don't tell him that. He might be happy.
Am I?
Yeah. This was a problem we had before.
Problems with my internet, Rumpus.
Yeah.
Yeah.
I told you to speak slower. I don't know if that helps or not. I don't know if that helps. And Rumpus, what happened to your avatar? You know you're going to get a fine. The other panel.
Oh right, yes. Sorry.
Yeah, the other panel members are going to be going cross at you.
Indeed, yes. I must. I find. Right. Okay. I'll go.
Yeah. What happens to people that don't have an avatar, Blue?
I don't want to find out. That sounds like trouble.
No, it's not nice.
Oh, Blue's in. Blue's coming to Discord, is he? All right.
No, he's in here. He's in Zoom.
Hey, Blue.
Blue's part of the furniture in here with the show.
Well, I can't. Well, oh, sorry. Hey, what? Oh, okay, that wasn't there. Oh, right. Sorry. Yes. Sorry, but I don't know. How have you only? Right. Okay. Yeah. Sorry. Did you appear about half an hour ago or something? Or? No, I don't know. I just didn't. I saw this Cavendish thing, and I thought that was Terry. Oh God, I'm all over the shop. Sorry.
How do you confuse a Rumpus? Throw him a Cavendish.
Yeah, sorry, sorry, Blue. I was thinking. I just thought that was a sort of a Terry avatar, something shoving in. I was about to quiz what that was.
No, I've got me Star Trail. I stick to that.
Right. How the hell do I change my avatar? Oh, there we go. Fine.
Okay. Do you need instructions? Because I know how.
No, I've got it now. I was struggling to find the damn thing. Let me sort this out while you do my. Well, you carry on anyway.
Blue is everywhere.
Can you
ask him to read his old message? What?
How's your plaque going, Blue?
Terry, can you hear?
Yeah, you're very robot-y, Paul. Sorry, Blue.
I haven't gotten anywhere on it, Rumpus. So.
Okay, I am having problems. I'm clicking on edit my profile inside Zoom, and it's not letting me change it. Perhaps it's because I'm in a call; it won't let me.
It is, yeah. You got, right. Yeah. I don't think you can change it while you're in here.
Okay, it'd be nice if it bloody told me that when I clicked on it. So, yeah. Right. Okay, I'll have to sort that out. So I can't change the damn thing, right?
That's okay. We do this to everybody. It's just fun to watch you guys struggle.
That's it. We like to see you struggle.
Yeah. Okay.
Well, you can always jump out, play with it, and come back while I'm sorting stuff out here for the next couple of minutes.
I might. Okay, and I got the.
We're getting a video ready and sort that out.
Okay, I might. Okay, I might go.
When I can get Paul back.
Okay.
Paul's gave us some new derp to play with, and I wanted to check to see which one I needed to get play. Where are we?
Rumpus is going to change his avatar.
Exactly.
Can you hear me, Terry?
Yes, I can
Terry,
hear you
is
now.
that any better?
Testing.
Okay,
1, 2, 3.
I've switched to a different Wi-Fi network other than my phone, so we'll see how it goes.
See how that goes.
Yeah.
I think they're following you around. That's why it keeps breaking up. I'm sharing that person's channel in here for you. That one.
Okay.
Is that the one?
Now, if you want to do a short one to start with, I'd recommend the one about scalar waves and debunking Einstein.
Okay.
Rumpus will enjoy that one.
Scalar. That one there?
Say what?
Yeah, that one, Terry.
That one there. I've got no idea, Blue. I just got here.
Oh.
Scalar
waves. I don't think I'm ready for this.
No, you're not, Blue. I can tell you.
I got no idea what's going on. This is Paul's dirt.
Oh yeah, this is almost as good as Lindsay.
What do we need? We need that. We need that. We don't want Rumpus to miss out on all the fun.
Very scary. Yeah, he'll be back in a second.
Yeah.
Parental guidance is suggested. as some language may not be suitable for fucking children. Okay.
Really?
Yeah, that's what it says.
Oh, okay. No, it didn't have the F word there.
Oh, I thought it did. Oh, shit.
Well,
good.
Well, did somebody guess the name, Paul?
They did. Carl got it, and Professor Phil Bell's got it too.
Mm-hmm. Okay.
George de Hevesy.
Okay, Rumpus has returned. And
there's Rumpus with a. He's got. Look at that.
Oh yeah, he's got his rumpus.
Yeah, he's got his clothes on.
Excellent.
Sorry.
I'm sure
No,
Rumpus.
that's all right.
I'm sure Rumpus has been on one of my live streams back in a long time ago.
So Rumpus, are you familiar with Lindsay Harris?
No.
You're a Lindsay Harris virgin then.
Yeah, he is. He
God.
definitely is.
I think I'm not. Yes, I think I'm not familiar. I'm not absolutely.
You would know, Rumpus. You wouldn't be able to.
So is this a scientist? A person?
No. But we've given Lindsay a bit of a rest. Maybe we should play one for Rumpus while he's here at some stage. But
yeah.
But this guy here is kind of along the ilk of Lindsay Harris, but he's nowhere near as bad as Lindsay. You'll enjoy this one, Rumpus. Have you got your oven mitts on?
I will stand well back from everything.
Yeah.
If you want to become a regular panel member, you're going to have to experience Lindsay at some point.
Right.
So
this is a flat.
Here's
or
Alan.
something.
Alan's here.
Oh, Alan's
No,
here.
it's not Flatty.
Alan.
I finally managed to unmute myself correctly.
Oh, that whole time you've been trying to talk.
No, not the whole time. I came off mute in the Zoom, but forgotten that I'd left the microphone on mute in voice meter because I was on the phone when I joined the meeting and I didn't want to come in because it always comes in with the mic on, doesn't it?
Yeah.
So I muted the mic as well and completely forgot about muting the mic.
Oh, you're excused this time, Alan.
Yeah, only if you watch the derp though, Alan.
So you ready for the derp?
Yeah.
Let's play.
Oh, I should have played.
Morning, everyone. Let's have some fun.
Oh, can we hear that?
Today we're going to play a bit about the Patent Office.
Oh, this is Lindsay. This is Lindsay's cousin.
Worked in a patent office. He got different patents together.
Can anyone hear that? Because it's very low on my end.
Yeah, it is a bit low.
Yeah, it's low on my end too.
You might have to turn Chrome up in voice meter, Terry.
In Banana.
In Banana, you got the. You should have in whichever channel you've got it in. You should have there's like a list of the applications that are using the channel, and they each have a voice. They each have a volume slider.
Yeah.
Although actually they're usually all the way up, so you might just have to turn the whole channel up.
Yeah, I'll try that.
There's a big slider at the bottom.
Collected the information and come up with E equals MC squared. The man's a thief. As all a patent office does, it's run by a government. They have the first read of your patent and they do one of three things for it. One, stamp it national security because they're going to get fucked. Two, stamp it national security and give it to the military and you got fucked. Or stamp it three, not viable because it economically destroys the country. You may, with a little bit of luck, get them to acknowledge it, but then they will only acknowledge something if it's not worth of anything to them. So that's why I tend to do everything public, because I don't give a fuck about the patent office. If anybody takes my technology and makes anything of it and makes it work, remember where you got it from.
I doubt whether that's going to happen.
There we go. I'll keep my lights running along the bottom. They are powered on a single wire, so you don't have to have two wires around a house. Only one. So that's half the cost of all the wire in the house. and I can add
What?
as many
One wire?
as I
What the
want, but I'll prove
How
it
can you have one wire?
this row here. Got some little numbers that we're going to fuck about with today, and that is the scalar wave or ion transfer. Forget electricity, it's old fashioned, it's a dinosaur, it kills you, it's dangerous, it uses horrible, nasty electron things. Keep away. You live on the planet Earth, and I use a calculation up here, what's known as an E1 to an E2. That's two wires, Earth on one side, Earth on the other, touch them on your ear rolls, bang, you don't go bang, okay? There's no power on them. But there's a resonance frequency on there with zero current or zero ampage, zero dangerous stuff. So if you've got a E1...
Is this bloke in the same institution as Lindsay?
He must be. He's in another room, I reckon.
Because all their rooms seem...
By the way, notice this guy who goes on about how cleverly he lights things and the terrible lighting he's got.
Yeah, I know. Yeah. Exactly. Yeah.
Yeah, those horrible little that horrible strip of LED lamps at the bottom, and that big reflection of the window that's directly behind him by the look of it.
Yeah.
Right over his left shoulder.
Yeah.
Boy.
And also, it's less than half the cost. If he's got one wire connecting to all these things, otherwise you would need wires to all of them. So you need. So for that thing there, you would need, I don't know, whether 8 or something, 6 of them. You'd need 6 sets of wires. So it's actually a lot less. But presumably they're just serially.
He's hooked them together in series, which is fine. But of course, to be really useful, what you really want to do is use a ring main, which is what we do. Which, yes, does use in fact, it uses 3 cables in the UK because we run Earth to everything as well, don't we?
Yeah.
But the point is, you can plug into it anywhere you like and run and then run a spur off of it if you really need to run more stuff. Just as long as you don't exceed the total current for the ring, which in the UK I think is 32 amps for the whole ring, and of course the limit of 13 amps per socket that you're plugged into.
I saw a program actually. There's an American who goes on about various inventions, and he talked about the British plug, and he talks about lamps and various pieces of technology. And he for some reason railed against the British ring main system because he was also railing against the way that Americans don't have fused plugs. So he was thinking it was marvelous we have in this country that every single plug you have is fused, and therefore whenever you stick things into plugs or you make extension leads, everything's fine. But in America, apparently you don't have fused things. So if you stick extension leads on things and it's not fused, you could blow up the whole power circuit.
Well, actually, you can kind of melt it all and set it all on fire. Which of course you can do here, but it's a lot harder to do here.
Yeah, with fused things, it's difficult to draw something stupid out of your ring main. And of course, that's fused as well. So, but I don't understand. So this thing. So the fact you mentioned ring main, as I say, there's some American who goes like, he thinks the ring main's are really a bad idea, and I never understood. I never saw a video about why he thought that, but he thought the our fused things were great and the American things were bad. This is an American, but he didn't explain why he thought ring mains were bad. And I was just wondering, possibly if perhaps Blue, who's obviously an American and knows a lot about electricity, might know why this is considered bad.
I don't really know why it would be considered bad. And yes, we do have the equivalent of, well, I don't know what you're talking about, a fused outlet. We've got GFI outlets.
Right, but not every. But if you have a piece of equipment with the plug on it, you don't have a fuse in the plug, do you?
No.
Well, as we do. So every plug you ever plug anything into a socket has a fuse in, which means that if it shorts or something, just the fuse will go in the plug. Not. Is
it a breaker or an actual fuse?
It's an actual fuse. It's
an actual fuse.
13mm cartridge fuse. Yeah.
Ah, well, that is totally stupid.
No, that's the sensible bit. That's the bit that he says is really sensible.
That is stupid.
No, it's not.
Make it a breaker, like a
Yeah, we got
so,
breakers.
See, here in Australia, we have a circuit that's got like they used to have fuses on the circuit. So back in the switchboard, you'd have a fuse, and you might have like 10 outlets hooked up to one circuit, but you might have 4 different circuits in your house. Yeah. There's a limit to how many outlets you can have on each circuit. But now, by law, you have, if you update or upgrade or install a new system, you have to have a leakage detector on your circuit board, on your mains board.
Yes, same here.
So it checks any fault along the system. So whether it be an earth leakage or whether it be a like a neutral leakage or whatever, it will instantly throw the breaker in the circuit board. So you don't need a fuse on each socket. You just need to make sure that the whole circuit is
well, we've got both
by that breaker.
All our plugs in.
We have both because we have the breaker on the circuit board with the ground fault.
Those
as well.
Those types of breakers are required for feeds to all of the bedrooms in a house in the U.S. currently. But we'll typically either you have a combination of 15 amp and 20 amp circuits in the house, and up to maybe 43 different circuits.
Yeah, so here we have only 10 and 15 amp, but then again our voltage is higher, so
right. Well, that's the difference.
But remember, US houses have 240 and 110 or whatever it is.
Yes. This is what this guy explained. Sorry. This is what this guy was explaining. You actually get 240, and if you so when he was basically railing against people hassling the Americans. He's saying you can't. No, we do get 240 volts in our American homes. It's just the way we have a thing on the what's it called, when you have something, take a tap on the center tapped or something to give you 110, but actually you do get 240 coming in.
That's right.
Yeah,
exactly
you
right.
need 240 for big stuff like washing machines and cookers.
Though we do have a big circuit. Sorry, we have a big circuit for our cooker. So, for instance, I've got an 18 amp feed to my cooker. So I think, although we say 10 or 15, I think there's usually one special circuit we've got for really something like an oven.
Or a hot water heater or something like that.
Yeah, immersion heater, yeah.
I think they go to 60 amps. I'm pretty sure that the socket circuits have got 32 amp breakers on, and the cooker's got 60. I could be wrong, but I'm not getting up and walking around.
Yeah, that's fine. No.
To look.
Yeah, that's right. Your sockets are about, I say, at least, I think mine's are 20 or something. But yeah, I think they go up to higher than that. And then the oven and the immersion heater have got their own circuit, and that's actually say I thought it was 18 for a cooker, but yeah, you might be right. Perhaps on some it goes more.
Probably anyway, let's have some more derp.
Yeah,
right. We haven't really got to the derpy bit yet.
What, haven't we? I think he's doing pretty well.
Oh no!
We're only 2 minutes into a 7.5 minute video.
This is not
square root of fuck all. Okay, nothing. If you take an E1 via an SEU, a scalar conversion unit, one of my toys, to an E2, you get big volts and big power. Don't call me a liar or a dirty cunt. We'll see you. Right?
Big power, right?
You're thinking, what the hell is he talking about, right?
Resistor through to a supercat back to E2, you get big storage. Fuck the battery wheels, bye Mr. Duracell, Varta, and all the rest of them. We use the alkaline, lithium batteries, NiCad. They're all out of date. That means all the countries where they dig out all the lithium on that. Bankrupt. Cheers, guys.
melting.
That's the first bit about the power. Now, what sort of power can you get?
Yes, Bandy, we're live.
Well, if you take an E1 and just dick around for your own little fun.
Yes, we are.
Across the E1 and E2.
Am I in the wrong channel?
No, you got to go into Zoom.
Not much, but
hold on, I'll do that and I'll come back.
Drive your phone off it if you want.
Mute yourself.
If you use 2 LEDs, you get something new. If you've got 2 legs on an LED, and you've got 2 legs on an LED, and you put them together, you end up with 3 legs. Ha! Fuck me! We've got 3 legs. We've got a plus, a 0 and a minus, which gives us a new ion state. You don't get that with electricity. You've got plus and minus, kill you or not. If you take 4 LEDs and you configure them in a certain way...
I'm confused. Has he...
Really?
Why are you confused? I was having an aneurysm. I'm sure I was.
A new ion state. I love that. That's and if this guy's replaced all of those batteries, I mean, just imagine how rich you would be on the patent
exactly
for that.
if it actually worked.
I mean, we're in the process of building a huge new battery farm or something in under control of Nissan or something in the northeast, where they're investing I don't know how many billion or whatever it is to build batteries for cars and things. I mean, just the amount of money you would get for some storage of this sort of thing would be. You would be the richest person on the planet times 1,000,000. I mean, Jesus Christ.
1,000,000?
Well,
a million?
You'd be. I was basically saying you'll be 1,000,000 times richer than the next richest person.
Who's the next richest?
I'm not. Well, I don't know. You need to cut. Bezos and Gates and all chucked together would be small change. For what money you would have. I mean, Jesus.
Well, who are you talking about, Rumpus?
This guy here. If his patent was correct, he would be the richest person on the planet times 100 or a million times more rich than anybody else. The next richest person. He would have more. He would have more money than most countries, I think, as an income, as a GDP. I mean, Jesus Christ. Imagine he'd be able to sell. His invention would completely remove all the need for cars and ships. Even you could probably drive ships off this instead of having diesel. I mean, you'd be able to replace every motor and engine in the world.
What is his invention? I've not heard anything yet.
Well, Terry's rewound the derp so we can hear it all again.
He has some storage.
He did that.
He could replace lithium batteries with something much cleverer.
What? Yeah. What the fuck is it?
I heard him mention.
He tied 2 LED legs together.
You just wait till he gets to Einstein's E equals MC squared diagram. You'll love that.
You ready?
Who are we watching? The Eye of God or something? Is that guy, that Orr guy?
No, it's not Lindsay. It's not Lindsay.
It's not Lindsay.
Or Euphorius, whatever his bloody name is.
No.
This is a new one.
Okay. Go.
That means all the African countries where they dig out all the lithium and that, they're all gone bankrupt. Cheers, Nige. Clean the world up. That's the first bit about the power. Now, what sort of power can you get? Well, if you take an E1 and E2 and just dick around for your own little fun and stick an LED across the E1 and E2, it'll give you 30% of the possible current that's available. Not much, but you can, drive your phone off it if you want. If you use 2 LEDs, you get something new. If you've got 2 legs on an LED, and you've got 2 legs on an LED, and you put them together, you end up with 3 legs. Ha! Fuck me! We've got 3 legs, we've got a plus, a 0 and a minus, which gives us a new ion state. You don't get that with electricity.
Wouldn't it be 4?
What?
Kill you or not. If you take 4 LEDs and you configure them in a certain way, you end up with a plus, a 0, a minus, plus AC, plus DC, plus ion conversion. Fuck me, that's a little bit.
Please.
What?
Stop the pain.
Now, if you take that
Stop the pain, Terry.
and use a bit of common sense, this stuff that up here that you were born with, it says,
Which clearly he's lagging.
Because you get a fucking bit. If you take
Stop
one
it.
LED,
Stop it.
I want to see him actually wire this up physically in front of us to what he's talking about.
No, please stop. It hurts.
It hurts. I'm laughing so much. It hurts.
I thought Lindsay was bad.
He is.
Oh, he's better.
New ion state, eh?
For God's sake, he's a chief petty officer in the Navy.
And you haven't reached the real derp yet.
Is he a flat earther, though?
No, he's not.
Oh, thank fuck for that.
Yeah, it's not that stupid, Alan.
It's too hard. It's hurting my brain, Terry. What the hell?
Come on.
Okay.
This is nothing yet.
Compose yourselves.
Commercial one, you get a plus and minus. Like this, plus and minus. Not very. It does stuff. It's clever. But if you take an LED and an E1 and E2, you get an inversion.
What's this E1 and E2 he keeps mentioning?
I'll explain what that is, because he does explain it in another video. What he does is he takes a wire and connects it to one part of your earth circuit, and then he takes another wire and connects it to another point on your earth circuit. And you know how you can have like a difference in voltage on your earth circuit.
That's
what he's using.
Definitely knew
That's
that.
what he's using. Yeah.
Yeah, I once found that using the main circuit as your ground for your oscilloscope plugged into one rack while taking oscilloscope readings in another rack, where the ground voltage difference was 55 volts.
What?
Makes it very difficult to set the kit up.
How did that happen?
Because all your DC voltages are way off. Because it was on a different. It was literally on a different circuit. Right. And the grounds were at different potentials, which is perfectly fine.
That can happen. Fine.
Yeah, it's perfectly fine. And it's not got any current. It's just because I'm using the other circuit's ground as my ground reference, I can't reference stuff to ground in the other rack because the other rack's ground is 50 odd volts different.
But normally, I mean, normally when you've got equipment, I mean, if they have a common ground, they plug into the same socket, which has got a common ground.
No. This is equipment racks in a radar site. And
but don't they plug into something that goes to ground?
Well, they're not plugged in. They're wired into the main system, but they're on different phases, so that if one fails, because the two racks basically have.
But even on two different phases, surely the ground is common, isn't it?
The two racks, no, because the ground comes. The ground doesn't necessarily come from this. It doesn't come from the same bit of circuit. It doesn't have to come from the same bit of circuit.
But don't they all plug into something? I mean, the ground in each one of those bits of kit, surely they plug into something in this environment together that then itself is ground, don't they?
Yes, but you can get, because they don't connect it together perfectly.
Yeah, even though that's the case, Rumpus, even though that's the case, Rumpus, you can have different ground potentials, and that's one of the reasons why it can cause problems with things like radios and audio equipment. You can get a buzzing sound because the grounds are at different potentials.
But normally that happens when if something like, I mean, I remember my sister, for instance, was doing something in on Uganda or something, doing some voluntary work over there, and she was setting up some sound equipment. And because they don't have proper grounds, they try and have a stake or something you plug in and have all the wires going to that to try and get a common ground. So yes, if you haven't got, if your grounding is poor, and as you say, you can get potentials between things. But I just presume that in your environment, Alan's environment, that whatever it was, lots of bits of a kit, somehow they're going into some sort of sockets that then go to something that then is common.
Rumpus, from the way I'm telling this story, could you not guess that that's what I thought too at the point?
I do indeed. Yes. Well, okay. I'm in your position now, and I agree with you. What the hell's going on? Why are these things common?
Anyway.
It was a.
Yeah. Anyway, so now you know what E1 and E2 stands for in this thing. It stands for Earth 1 and Earth 2. He's simply connected two wires to two different points on his Earth circuit. That's what the E1 and E2 are.
Right.
Okay.
On an AC circuit, not a DC circuit.
Yeah.
Yeah, but
what the fucking hell is an inversion? It means the plus goes to minus and the minus goes to the plus, or Vicky Verky. So you can flip the electronic polarisation in a circuit with an LED.
What was that word?
Now, if you can switch it on and off at will, that's a digital state. If you've got a digital state, you make computers that go on or off, yes or no, do this, do that. We're very easy. But if you now use a complex set of LEDs like I've got down here on my desk. You can have plus plus plus, plus plus minus, plus plus zero, plus plus minus plus a plus, minus plus minus, and minus plus zero, which is 6
what the hell
states.
What?
Did you get that?
And, or,
No.
if, nor, and XOR. Oh fuck me, is that not the computational state of all computers? With no hint?
No.
But this one actually does a calculation at 3 times 10 to the power of 8 calculations per second, or 300 billion. That's 300 times faster than the fastest computer that you've got today, with no heat. And because you can set these and you can configure them in any way, you can build a little box which is 100 by 100 by 100. Yeah? So you've got 1,000 on a layer. And as any two can create a condition, if you've got 1,000 less 1, you end up with 550,000 possible combinations per calculation, per layer, plus 100 layers. So you're looking at 500 million computational calculations with inside its own array that are occurring at 3 times 10 to the power of 8 computational calculations per second. This is 3-dimensional computational linear mathematics. A bit that you clever fuckers at MIT don't even know exists yet. This
there's a reason for that.
Quantum computing as archaic as a fucking stone wheel. Now, if anybody wants to come and test this, you know where I am. You can come and have a play. But all the proof is right in front of you right now. So just a quick one for that one. And I've got to make another one this morning, which is going to piss a few people off. Right, thanks for that one. Cheers, chaps. And ladies.
Does he finish?
Did you get that?
What was that word that he introduced? That polymize something or other. It. Oh. I mean, you don't know just where to begin, do you? I mean, he hasn't. The only thing he got right, the only thing he said was that the MIT were not aware of this. That was the one thing that.
Yeah, I wonder why they're not aware of it.
My goodness.
I have some thoughts on that, but
yeah.
I don't know which is worse for underbunkable, Lindsay or this guy.
Yeah.
Is this the same video that they're talking about the Einstein thing? Is this the same video? I think recently Simon Dan did a video. I think it looks remarkably like
this
that.
This is the same guy, yeah.
Right.
This is the same guy, yeah. Yeah. He's got a couple of other short ones too that are worth looking at.
Oh, well.
Oh, man.
Well, we had last week's derp, and I think this guy just topped that guy.
Yeah, yeah. Yeah.
That was yeah. What was it actually? I don't know. It hurt my brain too much.
These people never seem to get round. I mean, to claim that something like it's got the computational. I mean, you have to design CPUs and things.
Yeah, exactly.
Before you can get decide on what computational things you can get going. I mean,
they're the epitome of Dunning-Kruger, really, aren't they?
Yeah.
I mean,
well, he's going to build a new computer. I don't know how big it's going to be, though.
yeah.
So presumably he thinks he's drawing all this power from these two Earths having two different potentials. Is that his basic premise of this?
I think
seems like it.
I think he's very close to inventing the logic don't gate. Everybody knows what AND gates and OR gates are, but I think this guy has come up with a don't gate.
Right.
And the logic diagram for that says no matter what the input, you don't get no fucking output.
Or don't do this, or don't use this gate.
It's called a don't gate because it don't work.
Yep. No matter what you do to it, it don't do nothing.
Yeah.
Dunning-Kruger's really, as you say, his complete ignorance of anything on this subject is obviously empowered him to think he's got something, and thrashing around with this can compute this, it's got this much power, and it just, oh my God. I mean, this is what, of course, flatties do, is they actually like keeping themselves ignorant and not getting involved in all the messy things with science, because if they had to learn all that stuff, it's a lot of hard work, a lot of understanding, it just confuses you. It's much better just go with what you feel you want to exist. It saves a lot of trouble.
The other one that's worth watching, Terry, is the one right next to that one, using magnets for free power. You'll love that one too.
I'll put a vote to the peanuts if they want more.
Yeah, that's always the thing, isn't it? Free power is the other favourite of people who have no idea what the hell's going on. Yeah.
And I believe the UK Patent Office, along with the US Patent Office, will just
have stopped assessing things like that.
Will blanketly refuse to even assess it now.
Yeah.
That's why he was on about the Patent Office, doing whatever it was.
No, the patent office will not entertain an over Unity device.
All right, so Bandsaw Bandit says more.
Well, I mean, we are more used to 20. We are more used to 27 minutes and 13 seconds. Aren't we?
So Little Wolf says more. Yeah. There you go. My Mum Bakes Cakes says more. Dora says more. Do they want more, Terry?
Well, which way are you going? Because I've got it oldest to first, so you want me to go back?
The one that says using magnets for free power.
Yep, I got it.
Is Bandsaw Bandit the guy who lives near Whitesword on the south of the coast of Australia and was threatening to help him with this strange flat, this flat Earth experiment with which
I wasn't threatening to do anything. I actually there was no threat.
Yeah, Bandy's not threatening.
Yeah.
So it's a damn good idea. It's a damn good idea, Rumpus.
It's not, unfortunately, it's not a good idea, as I've tried to explain to poor old Whitesword. I think he spent $5,000 on some wire or cable or something. And he was going to do this very shortly and presumably engage people like yourselves help.
He has engaged.
Right. So has he? So is it 5,000 US dollars or 5,000 Australian dollars on this stuff?
Seriously, when people tell me how much it costs, I don't ask what currency they bought things in, Rumpus.
Yeah.
Well, if you have threatened, and not only threatened but engaged with this guy, presumably he's told you this. So I would imagine he's come from one of the first things he'd tell you. He said he'd show you all this cable he's got and say, "Look at this," and then go, "Oh, that's good."
He said it cost. He said it cost $5,000. He didn't say it cost 5,000 euros or 5,000 sterling. He just said $5,000. So
yeah, but the point is that whether it costs 5,000 US or 5,000 Australian, the reality is that it's 5,000 more than he should have spent.
Well, the thing is, the guy doesn't understand the geometry or the physics. And I said to him when he showed me this idea, was it 6 months ago? And I went through it with him. Initially, I was thinking, this might work. And then it took me about a couple of hours before I realised where the flaws were. It's not obvious, straight obvious why it doesn't work. And then then he brought it up again, I think a few days ago in one of the Discord servers. And I said to him, well, it's going to fail. And he said, oh, you're just being negative. And I said, no, actually, initially, I did support you doing it. But nonetheless, you will learn something. You will learn a bit about engineering, a bit about how to think, because he claims to have an engineer on helping him or something as well.
Oh, wow.
But Rumpus, in all fairness, a lot of scientific experiments where people think that they will work, and you'll have a lot on the other side will go, well, it probably won't going to work, but you won't learn anything unless you give something a go.
Yes, so I mean, for him, yes. But the thing is,
you've got to give him kudos for at least getting out there and do something.
I do.
Because
that's the point I was making.
All you globies want people to do stuff. So you should be giving him 100% support in doing it.
I do. That's why I said I do. The first thing I said, although this is guaranteed to fail, not just because the theory says it will fail, but because the practical consideration will also make it fail. I said, nonetheless, you will learn a little bit about this subject, a little bit about engineering, and a little bit about geometry. So that's good for you. and it means you won't be saying such stupid things to the rest of us. So it's a gain for him. I mean, he spent $5,000 basically on learning something. Well, okay, that's he's learned something. Which how do you value that? And so he will benefit from having spent that money, but it will fail for all sorts of reasons. But yes, I can fully support him doing it.
Well, you should try and help him do it so it doesn't fail.
But it can't work, I'm afraid. The theory says that it cannot work. And I tried to explain this to him.
Why can't it work?
Because I don't know if it's not okay. I don't know if he's changed it since I spoke to him, but he's going to, perhaps people are not aware of this, so he's going to try and have a line from a long line covering what 5,000 meters or something. And he's going to hold it up by some weights. And then he's going to measure the weight of the cable in the middle. Now, if you have a particular height, and if you have the cable on a globe earth, because of drop, the lines at the ends. So he's measuring the weight of the cable in the middle. So obviously on a globe earth, because of drop, those cables will be lower than the weight than the scales in the middle. So the idea is that on a globe earth it would be pulling down. And on a flat Earth, they would just be dangling. And so there wouldn't be, when they touch the scales, they wouldn't. Well, actually, he's not really allowed for sag, unfortunately, which means that also is another fundamental problem with the practical side of it. But the idea is that if it's flat and the scales are at the same height or just a little bit lower, they will have a much lower force on the scales than they would. But the problem is, of course, he's going to let the cables touch the ground between the thing that's generating the tension, i.e. a weight, 3 kilometers away or whatever, and the measuring scales. And of course, if it's touching the ground, that means there is no vertical force. By definition, if the cable touches the ground, that means that there is no vertical component. The weight of whatever the cable to that point is being resisted by the ground. And so you have no vertical weight pulling up or down. So whatever you did imagine if you consider the right to the right, imagine you're looking at this thing in cross section and you're looking at the scales and draw a picture and the scales in the middle, and you're off to the right, you have something that's generating a weight, and then between that weight on a pole is then touching the ground. Well, the vertical component's gone. If it's touching the ground, that means that the gravitational force the tension you're pulling, the vertical component, is now being zero because it's touching the ground. Because if it wasn't zero, it would be lifting above the ground. The mere fact that it's touching the ground means there's zero.
He's not reading gravitational force.
Yes, but the vertical component, which is what he's trying to measure,
Exactly.
Right, but that's become zero because it's touched the ground.
Well, if you've got the cable that's running along 5 odd kilometres long, and he's got a couple of sticks either side that.
Shall I draw a diagram? I've got a diagram here.
Okay, get the diagram. Okay. But basically, the vertical sticks each side account for the Earth curvature, and he reckons if he can pull that tight enough, that the scale in the middle should either read a higher weight or a lower weight if he can pull it tight enough.
Right, but lower high weight than what?
Well,
right,
if he has his sticks either side that are higher than the drop, so you haven't got those sticks there that are higher than the drop. You've got them cutting through the Earth there, from what I can see. I think the sticks are supposed to be higher than the Earth, which, if he can pull it, right, and get enough tension on it, and he can get enough tension on it, there should be a measurable difference on the scales in the centre.
But do you accept that in his experiment that the line is going to touch the ground? So can you see what I'm showing here?
Yes, yeah, I accept that.
Right.
Yeah.
Well, that means that then this becomes, as I've drawn here, all this bit about having. I mean, even if you were to raise this up further, so if you had this, this is 1.9 meters. I can't remember why. That's this height of his head or something like that. Yeah, that's his head height. I think he was thinking of suspending it from. Immediately it touches the ground here. That means that there is no vertical force. That you might as well just have a spring here or something. But
see what you've got there, where those poles are 1.9 meters long, right? They have to be longer. They have to be at the base of S, that box that you've got marked S. they'll be that high. That's how high they'll be, right? He's accounting for the curvature. So that line needs to go up higher.
Oh, right. So, okay, but yes, but the point is, he said that the line will touch the ground. So it doesn't matter if this. So if what you're saying is basically I should move this up here. Whoops.
Yes, yes, here. Exactly. Yeah, that up there. And
okay,
yes.
right.
And
but the point
line...
is, okay, and then but whatever he's okay, and then if you move this line, so if we edit this line here, and then we have it say coming like that.
So it's just touching the earth at the S box.
Oh, right. So no, that's not what his diagram has. He does not have the line.
Okay, no, that's what he plans on doing. So those poles account for earth curvature, and the line, if it's pulled taut.
Right. So you're now saying that's not. He's now changed the design. Then okay. So you're now saying that line, this line here will then do something like this. Right. Okay.
Yes.
Okay.
So that's a bit closer to it. Yes.
Right, but that's not the diagram that he has offered. If you go and look at the diagram of his design, he does not have this happening. He has the line touching the ground before it touches the scale. Now, this is different. Now, if this is the case, this is indeed different. What you're effectively doing then is. Then, in this case, you then have to decide what would be the weight on the scale in the two cases, which then means you need to work out what the sag is and what the effect of sag is. So you will then need to determine mathematically what value you should expect and then compare that to what you actually get, which means you need to do a very complicated calculation, which also allows for the fact that this is going to be blown about by the wind, even if this line is going to have to be so thin. If you're going to get this to be over 3 miles with a height, I mean, put it like this, I think I worked it out that you would need to have something like, if you can get this to be 10 meters high, 10 meters, I think, or no, I can't remember now, was it 6 meters? I can't remember now. You would need, it would droop. If you want a distance of something like 3 kilometers, I think I need, although I've got 2 times 5 here. You would need to put it up at something like 10 meters. If you've got the very best monofilament line that you could get, you would need to raise it up something like 10 meters to have it not touch the ground by the time it got to the scale, which I've got S here. And unfortunately, George bought some line, the best you can get. And he found it extended much more than you would want. And
I think the biggest obstacle he's got is the friction on the line and trying to pull it taut enough before it snaps. Because I think to get enough force in the line, and with all the friction involved, it's going to snap before it can.
It's not a friction issue. The braking, yes. Now I've done the calculations with the braking strain of the line that George got, which is something like 5 or 6, 7 times better than a typical fishing line, or the best fishing line you could get. He got some special monofilament something or other, and that had 5 times. And it's the key problem with the sag is the weight per unit distance, the mass per unit distance. Sorry. That gives you an equation for the sag. So what you will end up having to do, if you can get it to not stretch, which unfortunately is the problem that George has, he could not get it over the distance of 2 or 3 kilometers to not stretch to a ridiculous extent. It stretched much more because this line, although they talk about it having these characteristics, is not designed. They didn't think that people go out and start hanging it over 3 kilometers. They're thinking of it, just over a few hundred feet or something. They were given this value. But you now, if you're doing it over something like 3 kilometers, then the sag extends much more than that actually says. And unfortunately, that affects the calculation of that you're trying to do. So the measurement you've got to make, you've got to say, if it's not touching the ground, what weight would I see on the scale given the sag and all that sort of stuff? And so you have to do that calculation, which is then going to be screwed up by the fact that the rating they give for the wire, how much it extends, doesn't actually seem to agree with reality. And then you're going to have to, what you're going to do is a calculation saying, this is the weight we measured. This is the calculated weight that I've worked out thanks to talking to people who understand these things. and what would I expect on the flat Earth and the globe Earth? So unfortunately, you're not doing a qualitative measurement. You're going to be doing one that involves you testing your mathematical skills to work out what the scales would show. And I don't think any of you are up to that ability. And I know this engineer that White's Word knows, perhaps might know a bit more about it, but he's going to have severe problems with the behavior of any line that you've got that's stretching over 3 kilometers. And I think
you got everything. I think you got the stretching, the sag, the friction, everything is going to be is going to come into play. Everything.
Yes, but do you not understand the point I'm making? You have to do a calculation.
I do understand the point you're making.
So you're going to end up with a number.
Mathematics of it.
Yeah, so you're going to have to get the mathematics right, and you're going to have to, because you can't obviously change the shape of the Earth. So the only thing you can't put it in a flat Earth scenario and a globe Earth scenario. You've got one scenario, and then you are going to have to, with a calculation, say whether or not that's a globe or flat.
Yeah.
So that means you're going to have to get your maths right, and it's not a qualitative thing. Yeah. It's not as though the scale's going to show 0 if it was a flat Earth case and show a big value if it's a globe Earth case. Both of them, because you have sag in the flat Earth case as well, you would have to calculate what you think you would expect. And I'm afraid I don't think you're capable. Well, but certainly White's Word is not capable of calculating that value.
I'm not capable of it. Well, if you gave me the equation, I could probably work it out because you just type in the numbers. But me knowing what those equations are, no, I don't know.
And also, as I say, unfortunately, the equations are reliant on a certain stretch. You knowing what the stretch of the line would be, and unfortunately, over this distance, it would seem, according to George's real-world experience, that you can't work that out. You can't rely on the values provided in the because that change. If it stretches, it changes the mass per unit length of the wire, which means that it screws up your sag calculation. The sag calculation would then change what the scales will show. So unfortunately, but I mean, also, as I say, you've just changed the design of his experiment, because he was quite adamant in his drawings that the line would touch the ground.
Yeah, well, in this one, it would touch the ground too before he pulled it.
No, even after he made it taut, his experiment involved, even when it was taut, the line still touching the ground.
I think that was the first one. I think you're right there, Rumpus. That was the first one, but it was explained to me differently about 3 months ago that he had.
He brought the same diagram for the first one onto a Discord thing about a week ago. The same first diagram.
He might have gone back to it. I don't know. I haven't been around Rumpus, so he may have gone back to his first one. I don't know.
Okay, well, right, but if he's getting the line anyway off the ground, so he's trying to do this test, then yes, in theory, now theoretically, it could work. But unfortunately, the practice then unfortunately gets involved, and it means it won't work. But anyway, it's still, I completely support him trying to do it.
Yeah, and I think everyone should get behind him, because everyone is always crying for something to be done. So I reckon everyone should jump in his corner.
Right, but it will fail. But I'm happy for him to give it a go. And
happy for you to help. We know that you think it will fail. You keep on reinforcing it, but get in his corner.
But the thing to ask him, the key thing to ask him, if you are involved in it, which you seem to say you are, ask him, even when he makes it taut, is he hoping to lift the line off the ground when he makes it taut or not? Because if he doesn't bring it off the ground, then he's got a whole heap of theoretical problems. And as I said,
I think the first one, he was hoping that it would wrap around the Earth and pull down. So I think, with all the friction and all that involved, it was going to be a lot harder.
Yes, that was another problem. Yes, the friction, indeed. That's when the friction kicks in. Yes, that was one of the other theoretical problems, yes.
Yeah. So that's why I think he went to the one I just explained to you, where there'd be less friction involved, the tauter you pulled, but you still, the amount of force that you're going to have to engage on that line just to get it high enough, you're talking tons and tons of force.
It can't take you. The breaking strain. The breaking strain is you're not actually talking tons. Actually, I think the breaking. I've got 1,000 kilogram here. I can't remember what the. I think the breaking. Let me just what the breaking strain. I got.
Well, it's 1,000 kilogram. That's a ton.
Yeah, that is. I've drawn that there. I can't remember what the breaking strain of George's. Yes.
What do you think, Paul? What do you think, Paul? Do you think it's worthwhile giving it a shot?
Oh, look, my thoughts are that he'll set up the experiment, he'll take some measurements, but he won't have any clue about what the measurements actually mean that he's taking and how they relate to the experiment. That's my thoughts on it. That I think that's what's going to happen. That whatever measurements he'll take, he won't know how that actually applies theory-wise. So it'll be pointless him taking measurements because he won't have a hypothesis that he's going to actually test with those measurements.
But then someone like yourself, Paul, or Rumpus could jump in and take those measurements and extrapolate that on his behalf, yeah?
In other words, Paul's saying that what you've got to have a theory to say if it's this value, the Earth is flat, or if it's that value, the Earth is a sphere. So you need to calculate what that value will be, because it will not be 0 versus a number. It'll be a value versus another value, and then you've got to know what range is.
Could you do that, Rumpus?
Unfortunately, that's the point I was making. I don't know whether you absorbed this fact. I reiterated it 3 times. I'd say it again. Unfortunately, the behaviour of the light, to do that calculation, requires you to do a sag calculation, and that requires the mass per unit length to be known. And unfortunately, as it extends, you don't know what's happening. So unfortunately, that calculation becomes almost impossible.
Okay.
Put it this way, Bandsaw, there are much easier ways of determining the roundness of the Earth than this.
Okay.
Yeah.
I refer you.
I'll let it go. But I just think good on him. I give him kudos for at least giving it a crack. I
was thinking you'd probably buy a pretty good theodolite for $5,000, even in Australia.
You could buy a damn good one. Yeah.
A real nice one.
So, learn to use that and just measure some angles.
Well, anyway, it'll be interesting to see. It'll be interesting to see what transpires and what measurements he actually takes and how he actually sets up his experiment. But I think the thing that will interest me the most is how he documents it, because flat earthers are notorious for not documenting things completely.
Possibly. I think he's trying to be as open and as honest as he possibly can in regards to what he's doing, Paul.
Yeah, but look, I agree with that. There's a difference between being open and honest and not documenting it completely. Yeah, I'm not saying that I'm not saying that he's deliberately going to misrepresent what's shown or measured or whatever. I just don't think he has the background and knowledge in scientific experimentation to be able to properly document something like this.
Well, that's definitely a skill set that you have to know. Yeah. I'll agree there. Yeah.
What you were talking earlier, so I had to go away for 2 seconds. Paul mentioned there was an easier way, and of course, I don't know if you're aware of it, Bam. So I'm trying to do this rect thing, which based upon drop. This is my little logo, and it involves having posts like this. And I've done I almost managed to do it this year, this sort of live streamed event. And I've got these posts I've arranged at 2, 4, 6, and 8 kilometers along this Bedford Levels area. And from I am going to, in the spring, I nearly managed to do it at the end of the sort of summer last year. I've had a team of about 7 people, and we've constructed these posts which we can raise up and down. And using a theodolite, we're going to measure the drop at locations up to 8 kilometers away, which should be up to 5 meters. And from that, we're going to measure the drop, and thereby and we're also allowing for refraction and things. And from that, we can obviously determine the curvature of the Earth. And that you've got refraction that's annoying, of course, with any optical system. That was one of the reasons White was doing what he's doing, to avoid the refraction issues. But you can't, unfortunately, you can't really avoid the issue of trying to generate a straight thing, trying to work out something that's horizontal, which is basically the key to all these things measuring, is to say, if so this is basically So there's the basic thing. This is what we're trying to do here. Obviously, there's the Earth. You have a horizontal line. You say, well, okay, if we're measuring it curved, what's the drop? How much is it changing? How much is the Earth's curve changing from horizontal? And unfortunately, generating this horizontal reference line is the problem because, of course, with refraction, if you do it optically, you have that slight problem. That's what White's trying to avoid. But and obviously, if you want to do something, because the Earth is so flat, you've got to do it over something like, as we're doing with my thing, 8 kilometers. And building something physical that's 8 kilometers long is just out of the question. So unfortunately, you have to do it optically, and then allow for refraction. And obviously, the whole point of Wordsworth's thing is he was trying to avoid all this optical stuff and refraction by building something that, something physical. And unfortunately, to just build these things, and particularly for the line that he's using, it will be affected by wind, air movements, even if they're just convection things. And it will the effect of convection on a sort of 3 kilometer line would be greater than the weight of the line, or so you're just stuffed, unfortunately, if you're going to use a thin line. And you can't use a thick line because that's just too expensive. If you want 3 kilometers of chain, for instance, then at least you would get rid of all the stretchy things, and then you're effectively building a huge suspension bridge with a huge dangly thing.
Well, you couldn't pull a huge chain over 3 odd kilometers.
Well, you can, obviously, if you're building a suspension bridge, that's what they do. Or cable.
Show me a suspension bridge that's 3 kilometers long.
I think there were several.
The Humber Bridge, I think the Queen Elizabeth II bridge over the Thames at Dartford will be 3 k's.
Yeah, you thought so.
There's the Golden Gate in San Francisco.
And that's a pure suspension bridge. There's no pylons in the centre or anything.
Certainly the Dartford Bridge that Alan mentioned, I think, is over 3 kilometres, and that hasn't got anything in the middle.
Yeah, but I'm sure something that's 3 kilometres long is going to have pylons along the way. It's not going to be purely a suspension bridge.
No, it's purely suspension.
Oh, okay then. Okay.
It also has one hell of a sag in those cables.
Yes.
Yeah.
Well, you just got to look at power cables and how they are.
Exactly.
Yeah.
Well,
it's really simple. It's a really simple issue. You simply need to find a line that has no mass whatsoever, or you need one that you can apply an infinite amount of tension to. Either one of those will work.
Yeah. Actually, just something that's extraordinarily high. You don't quite need infinite. It doesn't need to be straight. A little bit of sag would do. If, of course, you can calculate what the sag would be. Now, that's the key thing. You need to be able to work out, so to quantify, as I say, otherwise you're going to end up with 2 numbers. In your flat Earth case and the globe Earth case, you can have 2 different numbers, and they both be something big, and then you need to work out what the difference is. But you need to work out what they are.
Yeah, you run through those numbers and put something 3 kilometers long out there. You will be shocked at how much deflection just adding a gram of weight to the center of it will do.
Yeah, it's saggy lines. So
oh my God!
It's quite something. Yes,
Geez, Rumpus, it sounds like you're talking about dating elderly women. A little bit of sag.
All right, guys, I'm gonna go. It's been good chat. We'll catch you in the next one, huh?
Right.
Yeah, we'll watch another derp. Hey.
Thanks for dropping by. Don't be a stranger, Bandy.
No, Terry. Thanks for inviting me, mate. I appreciate it.
Every Wednesday night, Saturday night, you know where I am.
I do. All right, guys. Catch us later. Be good.
Later, mate.
See you, Bandy.
Rumpus. The Bedford Levels is only about 40 miles from where I am. I would have offered to come and help. But it'd take me about 3 days to get there in my electric wheelchair.
Yes, Alan, I gathered that you would. Yeah, that's right. Because of course you used to photograph at that air station. I forget what it's called now.
I've got a lot of my photographs of aircraft at Duxford.
That's it, Duxford, and the other place that you were, which is obviously quite close to where this is, and the other. What's the other one? Airdrome.
The Shuttleworth.
Shuttleworth Collection. That's it.
At Old Warden in Bedfordshire.
Old Warden, that's the one I was thinking of. Yeah, I knew you were around there somewhere.
Where they have the... Well, actually, I'm right over on the East Coast.
Oh, are you now? Oh, okay.
I'm just north of the town of Great Yarmouth, right in the Norfolk Broads.
Oh, right.
About a couple of miles about a couple of miles from the beach.
Right. Oh yeah. Yes, I must. I did think of you actually, Alan, but I was aware that you were slightly compromised. But yes, you would have been useful there.
Yeah, I mean, I could have certainly been, sit on the bridge and look after all the kit.
Indeed, that would have been really useful. Actually, I don't know if you know, but on one occasion when it was about 6 months ago, on one of our first visits there, we put some kit down, the auto level and some computers and stuff, and then my sister was there looking after that, and she went away to check the while we were busy installing some of those posts there. She left a battery there while I was putting the kit away to ask about some Wi-Fi connections with the local pub to help them with our YouTube broadcast, and some wankers came along and stole the battery that was there. Bloody 80 quid's worth of battery. So yes, you cannot leave anything there. So and also I get a lot of people coming along and asking questions when I did it. I mean, last time I was there with WS and Farmer's Boy and my pal Nigel and some other people, a lot of people come along, so I need a sort of PR person there to fend off and also take measurements and things like I'm trying to take measurements of the vertical temperature gradient with a thermistor array. So yes, there's loads of things to be done. So yes, it would have been useful, but yeah, I'll see.
Yeah, it's just getting there because I'm not allowed to drive anymore.
Right, that's annoying, isn't it?
Yeah. Well, not being able to see and having sudden onset blinding headaches.
Oh God. Yeah.
That doesn't mix with driving a motor vehicle.
Right. Yeah. Okay. Well, that's a pity, Alan. Yes, it would have been. Yes, that would have. I was going to try. I did. I mean, I've got about 7 people at the moment recruited to do all this, and I've now got another 3 or 4 lined up for next year to do it. But yes, the more the merrier, and also just doing fun. Obviously, to make it sort of a bit of a party event as well. Because there's a pub nearby with a nice garden in it, and it's really nice, and so there's an ideal location there to get together and also broadcast, hopefully the champagne flowing after we determine there's a bit of drop there.
Just a shame you can't do it. You can't do it in the other direction off the bridge, in the direction that Rowbotham and what's his face did it.
I think I am doing it in the direction that he's doing. I think I'm not.
No, they did it. They did it the other way. Because
Welsh's Dam.
They did up to Welsh's Dam, yes.
Ah, okay. Yes, okay. So here's the map that I'm right. Okay. Here's the back of the thing here.
Yeah.
So here's Welney here.
Yeah. So you would literally just turn 180 degrees and point it
That's
the other
right.
way.
This going down here, it goes to Welsh's Dam about here. Yes. Right.
Yeah. Because the distance you get both ways is about the same. Because Welsh's about roughly halfway.
Correct.
But, yeah, the actual Rowbotham and I wish I could remember the other guy's name. They did it in the other
Carpenter?
direction.
That was the American.
Wallace.
Wilfred Royce is the one who had a bet with him. Yeah. Yes, Wilfred Royce. Indeed, I'm going to do a little. In fact, I'm doing a little history about that very thing. Actually, this is my presentation. I'll turn this into a video very shortly, so you might be seeing this more. Indeed, I'm going through the history of the Bedford levels, and here are some of the diagrams from Zetatech Astronomy from Rowbotham's books. I'm just doing it. Yeah, so this is a website I'm building that you can see at the moment. And yes, you're absolutely right. I was about to go and find out actually, and I knew which way they did it. And indeed, as you say, down here, exactly about the same length as I've got here. Salters Low. There's this gate here, the same direction there. Welch's Dam. But yes, doing
as
it.
Farmer said, you got too much trees.
Exactly correct. Exactly correct. All right, so that's why of course, right, from Farmers telling. So the bridge here at Welney, there are loads of trees in the way at this point here. This is the bridge. I'll put some pictures of that in there. So we're looking up this way, and there's a load of trees here now, and that's why I then decided to go this way. Thank God for that, because yes, the trees have been a real problem along here. Oh my God! I kept on thinking this was going to fail on numerous occasions because of trees in the way, but finally I've worked out a position on the bridge, because there's also this silly sluice. This is the view from the sluice. That's the view from the sluice from the bridge, with slightly zoomed in. This is what it actually looks like. That is actually the view from the bridge, and this dirty great big sluice gates in the way. And this tree here has been an absolute nightmare, cutting off this. But fortunately, what you can do is you can go just to the left of this sluice gate and look along that, and then see things.
It's kind of when you really want to go look to Anglian Water or whoever controls it. Look, just close the sluice gates for a couple of hours while we do our shit.
That would have been useful, yes. But actually, Actually, no, that would be useful because, of course, one of the things that people like Bev was one of the initial arguments they were arguing against this, as a sort of to preempt my observation, was that this is if you look at Google Earth, it actually gives. So if you go to Google Earth on here and you go to Wellman, you go and zoom into this section on the water, and then you move it along here, and you go to Salter's Lode over here, which is where the other end is. It gives this as being 1 meter lower than that, and of course, so then Bev was then saying, so it's not, it's a flowing body of water, because if it's a river, of course, and flowing, then of course one height would be different to that. And of course, fundamental to the whole of this observation is that the elevation of the two ends are the same. But of course, it turns out to be a problem with Google Earth, because of course Google Earth averages over a 90 meter square, and so of course,
I thought it was a 30 meter square.
No, it's a 90 meter square. It's 30 meters up and down elevation error. 30 meters up and down elevation error, but it's a 90 meter square they work on. Yeah, so the average elevation of this, so in other words, actually, if you go along here with Google Earth, it actually goes up and down by a meter or two every few steps. So obviously it's not doing that, but that was a line of attack that I'm ready to preempt from the Bev department. And indeed, of course, the reason, although it says it's a river, it's actually a drain, and of course, most of the time the water is absolutely stationary. And of course, that's what these sluice gates here are designed basically to deal with the fact that you can actually the tide can actually come the other way, it can actually flow backwards.
I know, because where I am, I'm right by the River Thurne, which rises about half a mile from the sea, flows southwest inland for about 6 miles, before then curving round and coming out again at Great Yarmouth.
Right.
And
okay, gents,
the bridge at
you need to wind this up soon.
Is tidal.
Right. And right, okay, so I'll stop. So the point is that some people are saying this is not a stationary body of water, which of course is absolutely required for my test, but it is. The sluice gates are there to make sure it's stationary or doesn't get it too overexcited. But yes, so I'm happy that they're up. I must admit, I'm so joyous that when I could see round the other side of the sluice gates to where the targets are going to be, I was jumping up and down with joy, because I thought at that point, before that, I thought, oh dear, this is all screwed up. I put all this effort in, it's all going to be buggered. And then finally I could get see the angles onto the targets. So but yes, I must thank you for pointing that out to me about the work. I was just about to do, as I say, for this presentation, the history of and I'd forgot, and I was about to go and find out which end he did, and I didn't know. But okay, so thanks for that.
Okay, well, we could probably talk about this all night, but this is not the stream for that. So we kind of got sidetracked a little there.
Yeah, unless it was an actual presentation that we could play that's already finished, which we will do.
I will do that. It's not finished yet.
Yeah, it's not finished yet. Yeah. Watch this space. We're going to watch one more of these other videos of this 432 health bloke. He's got a using magnet for free power, the polar equation of infinite power. So we'll just play the last one of that. This one only goes for 4 minutes 21. So I'll play this guy, and then you know what will happen after that. So we're going to kill your brain cells with this, and then you've got to work out how to get them back for the you know what after.
Yeah.
Righto. What's a 4-letter word that starts with P, Rumpus?
Pole.
Fell for the trap.
He fell for it. Okay. Play.
Good morning. Morning again. Friday the 13th. It's always good to bring some unlucky news to people, isn't it? This is a polar equation, and trying to understand how you can take a magnet, an aerial, and get power from it. To understand.
Did he say aerial?
He did say aerial.
Yeah.
He did.
His accent's a little bit. Yeah.
Understand it, you have to need to understand what's going on at the atomic level. We all know a chap called Mr. Einstein who said this. But this resides in a positive area. So you must have a positive and negative.
What?
And the reflective are the same. That creates a thing called CHEM. See it? C-E-M.
Chimp.
C-E-M. Only works in them quadrants. It doesn't work any other way. Just on these two lines. That allows for the four subpolar equations. You call them north, south, east and west, and the merge point between the two. That allows us to create what's known as a cone of convergence. See the yellow line? Yeah. It creates a diamond shape. The cones of convergence, the compression
points,
a
Ken Wheeler clone
points
or something?
in space, cylindrical, on all axes. This here is the estimated radiated power, or to look at it another way, it would be the minimum self-seduction zone of any two atomic particles in space. That produces the two polar fields that we work from today.
Who's been seduced? Who self-seduced themselves?
Fluffy bits at the top,
blah, 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 blah,
juicy
blah.
bits sit in the middle. So when we put a magnet, three-polar magnet, don't say they don't exist.
Okay, they don't exist.
Don't.
Can I say they don't exist?
Alan said it. Too late.
Alan.
Yeah.
It's impossible.
Three-polar magnet. We've got this configured as south, north and south, with compression in the middle. If you want to know how big the equation is, that makes this cone. If you take any point on E equals mc squared, it produces a triangle and the orthogonal view of itself. It can be here,
hold on,
here.
E is equal to mc squared is relevant to this. I wasn't waiting. I didn't see that coming. I didn't see that coming. I must admit. That came out of the blue there.
Well, he's got an equation up there, so it must be right.
I suppose. Yeah, I suppose I should have got it from the M. There's a C squared. There's an E, isn't there? Oh God. Oh dear. And Einstein said something's positive and negative. Fantastic.
Here or here. But it's quite complex how it plots all the positions of the infinite power sources. If you wanted to look at the cones of convergence, the yellow lines here, we can always apply this. Now this applies to one angle. Now I've got another 359 in that plane and 360 in that. So it's that times 359 to the power.
What?
There were only 360 angles?
Yeah, I was trying to work out.
It applies to one angle, and they said, and I've got another 359 in this plane. I mean,
but so he's working degrees, not radians, then.
He's working with.
He's working half a degree.
I don't think he's working. He's not working with
the decimal degrees. You can only have whole degrees.
Yeah. He's thrown in a lovely series.
Yeah.
360.
What's that an expansion on?
Draw that.
Is that sin X?
I don't know. I can't see the.
If you wanted to look at the estimated radiated power or the inversion or the minimum self in screening range, that's this one here. Again, it's 360 times 360. It's a huge equation. But at the end of the day, without all the numbers, this is what happens. You get a negative ion flow from the antenna to the polar field. So
where did this antenna come from?
Yeah, I know. I'm trying to work out what.
Suddenly we've got an antenna out of nowhere.
Where's the antenna?
No, you did mention it at the start. It's on the circuit diagram.
Oh, right.
You want to go back to that, really?
Compressed in the middle.
How's he got south, north, south on the fucking thing?
Didn't you hear him? He said he had 3 poles. Didn't you catch that bit about a minute
ago? It's a three-pole magnet.
And I just laughed.
Yes. Yeah. You're too busy laughing to take it in. Yeah.
Yeah.
If we make a belt here to click off the polar field, and then we take another one through the 3 gaps in the middle to take off another polar field, we can pull off all the power we want from now to the end of time. And to simplify the view, the air is full of ions. You suck them in through one magnetic field, you invert them, and you put them out through the same magnetic field. And it works on the same equation. C, E.
This is so similar to Lindsay's bloody toroidal donut.
Yeah.
I'm sure they're related. They have to be related.
This is worse.
Well, are you all familiar with Ken Wheeler, the sort of calls himself something Theopolis or something?
Yeah,
Yeah.
Magnetic Festa.
Yeah, that's it. Magnetic Festa. Yeah, exactly. This guy's just following in that. I bet he's seen those videos and thought, I can do the same as that. I can make up bollocks.
Yeah, exactly.
Bollocks too. Yeah. And point of convergence. I mean, what was his favourite Ken Wheeler's things? It was he has toroidal stuff and vortices and there's something counter space, which he got off some idiot some guy that he got it off, who a bald some white-haired guy who talked about counter space, which turned out to be something to the power of -1. You're right.
No, let's finish this off.
M C E M C E M. It doesn't matter where we put this cloud, it will always produce power at the exact opposite point. And if you tap off the power in the middle, you get infinite power from now until the end of time. Thank you very much.
I think he needs to spend time.
Did I miss anything when I had to nip away there to answer the door?
No, I don't think you did.
Nothing.
But you're gonna get enough power to last you from now till the end of time.
Yeah, I heard something about that, but
so you can collect your eons, and they'll go in at any end.
Ions.
Ions. Sorry.
Ions.
Applications, onions.
Oh, jeez.
I mean,
he's
managed to avoid. I mean, there's nothing on that. I suppose he's drawn an antenna. I mean, I don't know if Alan would tell us that that's the correct diagram for an antenna. But that's the only thing.
That is certainly, looking at his age, that is certainly, and if he was indeed, as Colon said, a radar technician in the Royal Navy, he is of the right age that would be the circuit diagram symbol he would have learned for an aerial.
Right, but everything else on that diagram was wrong. I mean, it's just
bollocks.
You'd have thought that you accidentally get something right, but no, he managed to get ion flow. Wrong. Yeah, I mean everything. I mean, you have to be trying quite hard to get everything. I mean, we've got a diagram. We've just got a short between the two ends, and what we've got an ion flow when in fact we've got a magnetic field. Another ion flow.
And I don't know whether anyone picked this up either, but if you have a close look at that graph, it was obviously referring to E equals mc squared, which is, of course, Einstein's famous equation. Now, on the graph, it's got the horizontal axis labelled c squared. It's got the vertical axis labelled m. And he's drawn a parabola, or part of a parabola on it, which, of course, E equals mc squared is a parabola.
Paul.
But you don't what?
Paul.
You're breaking up.
Paul.
Yeah. Okay, I'll try changing connections
again. Yeah.
Yes, I hadn't realised that. That's where the E's are going, because we've got E going up in a parabolic in proportion to
c squared.
Yeah, c squared. Yes. No, actually, that would be linear, wouldn't it? Sorry. Yes, if that was the E's.
Yeah, exactly.
Yes.
If the axis is c squared, then it should be a straight line.
Yeah.
If I remember correctly.
No, you're absolutely correct, Alan. Absolutely correct. Yes,
but personally, I would kind of wait for Paul to come back, just to, because I make stupid mistakes with that sort of stuff these days.
No, you're right this time.
Okay, can you hear me?
Yeah.
Yep. We can.
Okay. Yeah, what I was pointing out was probably what Alan's already said, that you've got the horizontal axis labelled c squared and the vertical axis labelled m. Right. Yeah, like Alan said, it should be a straight line, not a parabola in the middle there. If you plotted E on the vertical axis and then you would get a parabola. Yes, but no. The way you had it was wrong.
Yes, but actually these two things are M and C. So E hasn't. You can't. You can only plot. Well, I suppose no. Wouldn't the gradient? Wouldn't it be one? Hold on.
Well, no. The plot would be the plot is E, because that's what that's what you get if you multiply M by C
yes,
squared.
I suppose. Yes, I suppose.
But
so.
it should be a straight line if the axis is C squared, and then of course it would be a exponential curve if it was plotted as C. But I'm
a bit intrigued by this negative C squared.
Yeah, I know.
Yeah.
Well, he's got an equation there. There you go.
How that happened?
How do you get negative C squared?
Yeah.
I think my brain just exploded.
Okay.
He's every bit as good as Lindsay, though, isn't he?
Yeah.
Oh,
I reckon he's better than Lindsay.
Paul, having some understanding of the subject, I think it hurts even more. That
Good.
He's just taking such liberties.
You wait till you see the hour-long one that he's got, though. You'll explode.
I think we're going to have to break that one up or play it fast forward. Lindsay speed.
Yeah, play it fast forward. It's okay.
Yeah. But not tonight.
Yeah.
Not tonight.
Yeah.
What the hell is L?
You're going to try to make sense of that. Do you want me to print a picture for you, Blue, and you can study it for homework?
Right. Hold on.
Hang on. Colin says, hold on. He says he's debunked time.
Hold on. This E is equal to MC squared thing. If we've got two things we've got M and C squared, then in fact E is 1 over the energy.
No, but when you
remember, we've got a graph here of E against C squared.
With the axes he
sorry,
put there,
M against C squared.
No, M against C squared. So
exactly. So therefore, it's
you basically rearrange it. You take the C squared over the other side, right? So you get M equals E over C squared, and so you have a constant there of a constant of proportionality, which is just 1 over C squared, right?
Well, we know we must have.
It's just M equals a constant times E. Okay. So it's literally a straight line. So you should be getting a straight line for that graph.
But C squared. But we've got a plot of M against C squared.
Yeah, that's what I'm saying. So if you rearrange that to get your M on one side and your C squared on the other side, all right. Yeah.
And it's 1 over E.
Oh yeah, you're right. Yeah, because yeah.
I think Phil's trying to figure it out too. Don't break your brain. Don't break your brain, Phil.
I know you've got. It's hold on. This is ridiculous.
Don't even try. Yes. Don't even try to make sense of it.
Yeah, Rumpus, you're thinking about.
That's the mistake you're making.
Yeah.
The mistake you're making is to try to make sense of it.
Yeah, no. It then became an interesting, proper problem rather than the stupid one. What exactly would, if you were trying to plot M against C squared, what you would get? But rather than I wasn't trying to make yes.
Can I just mention quickly a Clive Wells post? Terry, he says you need to break the hour-long one down into chunks of 27 minutes and 13 seconds.
Correct.
Yeah, that's right, to match a Lindsay video. Yeah. All right.
Yeah, because Rumpus, Lindsay's videos are usually 27 minutes and 13 seconds long.
Good grief.
Because we think that's the maximum he can get onto his
memory card.
On his memory card.
Right.
So you're definitely going to have to come back. Can you come Wednesday nights or your Wednesday morning or Saturday mornings are better for you?
I think it was a question to you, Paul.
No, for Brumpers.
No.
Oh, sorry. Oh, me. Sorry. Oh, right. On Wednesday nights or Saturday nights? Possibly.
This time on a Wednesday or this time on a Saturday, because that's when Terry streams.
Okay. Yeah. Okay. I might be able to manage that. I might be certainly able to do Saturday. I think. Yeah.
Yeah, one or the other doesn't matter.
We'll have to pop your Lindsay cherry.
Yeah, we definitely do. We definitely do.
I must admit, I found 5 minutes of this quite demanding. I think 25 minutes might be more than I can take.
Oh, you got no hope, Lindsay. Then. Oh man.
You're gonna have to get some oven mitts for Lindsay. That's for sure.
Yeah. But at least Lindsay gives you bums and boobs.
Oh yeah.
And
yeah. All right, moving on.
As well, of course.
How are we ready for a quiz?
Yeah.
I don't know. I don't think Rumpus is ready for the quiz.
It's not a science quiz. It's not a science quiz tonight. It's a music quiz.
Oh, you missed out on the science quiz, Rumpus.
Oh my God, I know nothing about music at all.
Oh, don't you?
Oh, okay. You'll have. Yeah, well, we do get science quizzes, so you'll have to wait for that. Quizzes. So you'll have to wait for that
stage. Yeah.
I did once say I'm absolutely crap at the music quiz, and I actually got a few questions right, so I was really surprised. So,
well, I'm more crapper than you, then, Alan, because I don't think I'll get any right.
Yeah, you're definitely better than me, Alan. I think you're ready for that.
Yeah. Oh.
Okay.
We better tell Rumpus how to do it.
Oh yeah, Rumpus in the the internal chat that's linked with Zoom. You can go to chat.
Yep. In Zoom, not Discord.
No, not Discord. So in the chat, where it's got to everyone, change that to George D. Hevesy. Yeah, and that's where your answers will go directly to Paul, and then he'll read the answers out when the peanuts catch up, putting their answers out.
Okay.
Because of the delay to YouTube, we're also not allowed to say the answers out loud.
Yes.
Right.
We can infer, but we can't actually say the answer.
Right. Yep. Okay. So I've got Rumpus's hello. He's
okay.
Hello. So he knows what he's doing.
Yeah.
Okay. So the way this quiz works tonight is I'll give you a description that describes the song and the artist. There'll be certain words that are kind of like blanked out with the first letter still visible, so it gives you some kind of a clue. The idea is you've got to tell me what song and what artist I'm representing. If after the worded clue you still have no idea, I'll give you a picture that'll give you some sort of clue too. And after that, that's it. That's all you get.
Okay.
But you should be able to. There'll obviously be some easy ones, and there'll be some pretty damn hard ones too. So we'll go through one, for instance. Like here's the first clue for the first question. Now you see it says number 30. That's because I've made a list, according to my tastes and other research, of the 30 best songs of all time. Okay, so this is number 30, and we'll count down to number 1. So this is question number 30. So I've always been fascinated with aristocracy. All right, so you can read the thing there and see if you have any idea who this artist is and who the song is. Told Rolling Stone around the time that this particular song came out of nowhere to take number 1 spot on the US charts. Written in like half an hour by a 15-year-old New Zealander taking influence from the diamond-encrusted swagger of Kanye West and Jay-Z's Watchline. The Throne, as well as the muted electronic work of artists like James Blake. Any idea who this artist and who this song, or what this song might be?
Not a clue.
Not a clue.
Yeah, we've got a clue, Alan. You can't say we haven't got one.
You do have a clue. All right.
It doesn't constitute a clue, I'm afraid, for me and Alan.
It's not Lionel Richie. Hello? No. Here's your picture clue. Do you know who that is? Any idea?
Nope. Absolutely
none.
But I think this is of a magnitude more difficult than I can cope with.
Oh,
yeah, me too.
There'll be some easy ones. Someone's got it. You see, there is always a smart person out there. It is, in fact, the song Royals by Lord. You know the song now? Do you?
No.
Right. Oh dear.
This is an order. As I say, I'm crap at music. Alan is probably a magnitude better at this than I am. And...
well done. Well done to Fred Knotts and Dora New, who got it out there, and Biggest Doggers. Yep, they got it. So some people do know. Okay, song number 29. At the intersection of past and future, West Coast hip-hop sits Somebody. Debut solo single, a smooth and inimitable kickback classic that could help define his career. Following the demise of NWA, in a radio interview, the producer and rapper revealed that the song originally sampled a track by Boz Scaggs before he settled on the bass line from a Leon Haywood's 1975 hit, I Wanna Do Something Freaky to You. Somebody was in jail while this song was recorded, so he had to originally record his parts over the phone. Any idea what this song is and who the artist is?
I'm going to give my stock response.
You don't know.
But the funny thing,
I'm with Alan again on this one.
The funny thing is that I've seen that you can hear the jail sounds in the background line.
Yes, that's right.
About a song very damn recently.
Yes.
But I still can't remember what it is.
We do have somebody who knows the artist. Well done to Carl Edwards, who has got Dre. With Snoop Dogg is very good, but what's the song? Anyone know what the song is?
Hey, Rumpus, we'll just have to wait till the science quiz.
Yeah, I think so. Yeah. I think I'm just going to be a dead weight here.
Yeah, me too.
No, and it was Dr. Dre featuring Snoop Doggy Dogg with Nothing But a G Thing. That was the song. Okay.
If they don't play it on BBC Radio 2, it's like past me.
Okay, number 28. This artist had a difficult time bringing this song to life. The song began during jams at Compass Point Studios in the Bahamas as the band worked on its groundbreaking Afro-funk influenced album. Producer and co-writer Brian Eno wanted to ditch the tune altogether until David Byrne started performing his Same As It Ever Was monologue. That should give it away. Like an evangelical preacher, which somehow sharpened his message about questioning identity and reality. We're largely unconscious, the singer once said. You know we operate half awake or on an autopilot and end up whatever, with a house and family and high and everything else. And we haven't really stopped to ask ourselves, how did I get here? Anyone know what the song is?
Oh, Rumpus knows what it is. Rumpus, what is it?
No idea.
At least I know what damn song it is this time.
Oh, you do.
Oh.
So you know that the line goes, same as it ever was. Same as it ever was. Same as it ever was. Over and over again, right?
I think it's from the 80s, isn't it? Because I have a feeling that it was on Now That's What I Call Music, either 1 or 2, possibly maybe 3. Because I had them in the car back then.
There you go. Fred Knott says I'm singing it, damn it.
Yeah. But
yeah. And Carl Edwards has the group. It's the Talking Heads. Yes.
Yes, I thought it was Talking Heads. Yes. Oh, God.
Yep.
Oh, sorry, I didn't know that.
And do you know the song? There's kind of a part title out there from Carl.
I only know
Lifetime.
The Road to Nowhere. That's the only song I know of theirs.
No, it's Talking Heads, Once in a Lifetime. You probably know the song now.
Nope.
Okay.
I know the Same As It Ever Was bit that goes on.
Yeah. Okay, number 27. This song's 4.5 minutes took 3.5 months to cut. Aiming for the impact of Phil Spector's Wall of Sound, this particular artist included strings, glockenspiel, multiple keyboards, and more than a dozen guitar tracks. I had enormous ambitions for it, said this artist. I wanted to make the greatest rock record I've ever heard. This artist's lyrics told a story of young lovers on the highways of New Jersey. I don't know how important the settings are, this artist said. It's the idea behind the settings. It could be New Jersey, it could be California, it could be Alaska. Anyone know what this song is?
This probably could be. I may have even heard of this because Phil Spector's Wall of Sound did do a song that I really like, and I've forgotten what it is now. But that is a very famous song. If it's I have no idea what it is.
This should give you an idea of the artist. Who's that?
No idea.
No?
It's not Eric Clapton, is it? No.
It's not Eric Clapton. No.
Who's that? It's 60.
I'm glad you were wrong then. Velvet, you said it out loud.
Velvet Underground. It's not Velvet.
There you go.
Velvet Underground chap, is it? No.
We have a winner in the Peanuts.
Not Lou Reed.
No, but we do have a winner in the Peanuts. Well done to Vroomfondle. It is Bruce Springsteen, Born to Run.
Oh, Springsteen was his last name in the clue, not his first name.
That's right. Yeah.
But come on, everybody calls him Springsteen, don't they?
Do they?
Yeah, they do.
I don't know. I wouldn't have a clue.
Yeah.
Oh, well, have you ever heard him referred to as Bruce?
They call him Bruce.
Hey, Bruce. What's up, Bruce?
They call me Bruce.
What's the first rule, Bruce? No. 26. One of the many searing moments on this artist's landmark track, right, unsparingly grapples with conflicted feelings and entangled identities. The male character in the song is apparently a composite of several men in her life during that time, notably Leonard Cohen and her partner at the time of its recording, James Taylor, who joins in on guitar with this person herself on dulcimer. She later dismissed this song as a doormat song, and yet it remains one of her most beloved. Prince, who once said that this artist's music should be taught in school, if just from a literature standpoint, covered it several times during his career. Who is it? It's not Madonna, Alan. No. The M in the clue refers to her surname. The J in the clue refers to her given name. Fred Knotts has the correct artist. It is, in fact, Joni Mitchell. Yes. Well done, Fred. But do you know the song? Something. Oh, something. No one knows?
Yes. Of yes.
Not yes. Can you think of another Y word that's got 3 letters? Can you think of another Y word that's got 3 letters?
Of you.
You, yeah.
A copy of you.
Not a copy of you.
If you think you've got it, type it in.
A blank of you. No, you can say it out loud now.
Okay.
Cone.
Yeah. No. It is Joni Mitchell with A Case of You. There you go. All right, number 25.
So who got that out in the peanut? Okay.
Well, I'll give it to Dave Cannabis and Fred Knotts, who actually got the artist, but no one actually got the title of the track. Okay. This artist had always generated controversy and criticism, but after he interrupted Taylor Swift at the 2009 VMAs, his public image was at an all-time low. So he took off for a self-imposed exile in Hawaii and recorded his 9-minute masterpiece, a toast to the douchebags and an unguarded reflection on his image and intimacy issues. The song sounds like it's talking about a girl, Could also be talking about my relationship with society or my relationship with the fans or anyone who I let down or people who had to defend me that really loved me. Such and such said. He was so impressed with this song's tease, this collaborator tease guest verse, that he signed him to his Good Music label and eventually made the Clips member president of the label. Who is the artist and what is the song? Anybody know?
Alan, you can't phone a friend.
Alan's phoning a friend.
Yeah.
Yeah. We have a correct artist out in the peanuts. It is, in fact, Kanye West. Do you know what the song is? Are people still there, or have I dropped out?
No, you're still there. We just don't know.
Okay. Okay. All right, so it seems like people know the artist, but they don't know what the song is. The song was actually Kanye West featuring Pusha T with Runaway. Okay, this one. This song was one of the last true such and such artist collaborations. This artist wrote the opening and closing sections, and another artist contributed the woke up, fell out of bed middle. For the climax, they hired 40 musicians, dressing them in tuxedos and funny hats, and told them that they had 15 bars to ascend from the lowest note on their instruments to the highest. Listen to those trumpets, they're freaking out, a certain fella said. The final piano chord concluded this particular character and made rock's possibilities seem infinite. Who was the artist and what was the song? Anyone know? This is probably a very, very well-known band. And yes, you're right, Clive Wells. It is Lennon and McCartney that are involved here. That should tell you what the band is. Now, what's the song? You have the first letters of all the words in the song.
Is that Day in the Life?
It is, Rumpus. Well done. You've got your first win, man.
Bloody hell.
Yes. There you go. It is
Good
the
grief.
Beatles with A Day in the Life. There you go. All right, number 23. After a coke-fried spell in Los Angeles, this artist was detoxing in Berlin when he spied two lovers having a rendezvous by the Berlin Wall. Said this artist, I thought of all the places to meet in Berlin. Why pick a bench underneath a guard turret on the wall? Imagining the story behind their affair, this artist wrote his most compassionate song ever. The song builds for 6 minutes with this artist setting his ragged, impassioned croon over a throbbing groove consisting of Eno's humming synths, Robert Fripp's guitar, and producer Tony Visconti banging on a metal ashtray that was lying around the studio. This artist wails with crazed soul about two doomed lovers finding a moment of redemption together just for one day. Who is the artist and what is the song? I'll give you a picture clue. That should tell you the artist.
Bowie.
That's Bowie. But what's the song? You're going to have it in your head from now on after you find out. It's not Satisfaction. It's not Starman, Carl. No. Not Little China Girl. Those words, "just for one day," feature in the song. No idea?
No.
There you go. We finally have it from Dave Cannabis in the
Yeah.
Peanuts. Well done, Dave. It is David Bowie, "We Can Be Heroes," or Heroes. Yes. Yeah. You know the song now, don't you? Yeah. Okay, number 22.
Vaguely, that one.
Yeah. Phil Spector rehearsed this song with this artist, the only one to sing on it for weeks. But that didn't stop him from doing 42 takes before he was satisfied. Aided by a full orchestra as well as a young Cher who sang backup vocals, Spector created a lush, echo-laden sound that was the Rosetta Stone for studio pioneers such as the Beatles and Brian Wilson, who calls this his favourite song. "The things Phil was doing were crazy and exhausting," said Larry Levine, Spector's engineer, "but that's not the sign of a nut, that's genius." Now this is a bit of a hard one. I'll be impressed if anyone knows which group and which song this one is. I'll give you a picture clue. Do you know who these are?
Not the Supremes, are they?
They're not the Supremes, no.
Isn't that who? Is that the people who did that song about that played at weddings? Oh God, they're called the Somethings.
They are called the Somethings, yeah. Except replace the words. Replace the word somethings, which starts with R.
Sonettes or Donettes or Rosettes.
No, you're getting very close, very close, Rumpus.
The Rosettes.
Not Rosettes.
Donettes.
The what?
Donettes.
Not the Donettes. But that's extremely close. Wrong letter to start with, though. Not the Rockettes, no. I'll give you a hint. Right? The band was formed from a guy called Ronald.
Rosettes. No, it's not the Rosettes.
No, come on.
Oh, God.
I said you were very close when you said Donettes,
yes.
But you had the wrong first letter. Now, if it's named after a man called Ronald, what do you think these girls are? They are the
Ronettes.
Exactly, the Ronettes. The Ronettes was the band, and the song was "Be My Baby."
That's it. Yes, that's the song.
Yeah.
Yes, Be My...
Yeah.
That's that one played at Wellington. That's one. Yes. Oh my God, I know.
Yeah.
Bloody hell.
All right. Question 20. Swedish disco queen something captured all the agony and ecstasy of twirling alone in a corner of the dance floor, spinning around in circles and losing yourself in the heat for a moment of solitary triumph. I think this song is totally from me, just being in clubs and going out and dancing a lot and seeing people and thinking, what are they doing here? She said later. Written with Stockholm producer Patrick Berger, the song made this artist an iconic cult hero, but it also became the template for a whole generation of young songwriters, from Taylor Swift to Lorde, looking for the ideal glitter and sobs cocktail. This song to me is perfect, Lorde wrote. Joyous, even when it is heartbreaking. Who is the artist? Swiss artist? And what is the song? Oh, they're too good out in the Peanuts. It is, in fact, Robin, Dancing on My Own. Well done, Peanuts.
Never heard of half these people.
Yeah, okay. 19. It's not like he thought, oh, this can be an anthem. This person recalled years later of this song's creation in March of 1971. This is an easy one, by the way. This particular person This particular song, was just what this person believed, that we are all one country, one world, one people. He wanted to get that idea out. This person admitted that this song was virtually the Communist Manifesto. But the elementary beauty of his melody, the warm composure in his voice, and the poetic touch of the co-producer Phil Spector, he was pretty good, that Phil Spector, wasn't he? Who bathed this person's performance in gentle strings and summer breeze echo, emphasised the song's fundamental humanity. This person knew he had written something special. In one of his last interviews, he declared this song to be as good as anything he had written with the other group that he was a member of. And yes, they have it right out in the Peanuts. They're right onto that one. It is John Lennon's Imagine. Well done, Peanuts. See, they're onto it. Number 18. We've got intelligent peanuts out there, you know. On the 1999 tour in 1983, that should give you a clue as to who this artist is. If you have a 1999 tour and the year is only 1983, who's the artist? Found himself sharing arenas with Bob Seger, and he challenged himself to write a Seger-like ballad, but instead of night moves, he channeled a heart-rending meditation on love, trust, God, and something else. It was so different, the Revolution's Bobby Z said. It was almost country, it was almost rock, it was almost gospel. The version of the song on the album soundtrack is actually a live recording from 1983. And yes, I'm not even going to read the rest because the Peanuts have it already. It is Prince, and the song is Purple Rain. Well done. And we actually had a few people in the internal get that one too. Well done, Terry. Except he wrote Princer. It was Prince of the Revolution, Purple Rain. Yeah. Okay, number 17. The 1970s rock's most grandiose decade never got more grandiose than here. This particular song contains a reported 180 vocal parts and spans rock, opera, heavy metal and pop, all in 6 minutes. But for as elegant as it sounds recording, it was a literal mess. This particular singer taped scraps of paper containing his own bizarre musical notations to his piano and simply started pounding out chords for his bandmates to follow. Somehow he pieced it all together beautifully, singing about killing a man, possibly a metaphor for obliterating the heterosexual image of himself. You know who it is?
Yeah, I've got to type it first.
I'll let you answer before I tell you that the Peanuts have got it right.
Oh, they've already done it.
Oh, they really have. They're right on this one. Yeah. And it was Freddie Mercury, yes.
Bohemian Rhapsody.
It was Queen with Bohemian Rhapsody, yes. All right, number 16. Producer Rich Harrison had trouble convincing friends and peers that the beat to this particular song had much potential. So he added a 5-alarm horn blast taken from 70s soulsters The Chi Lights, Are You My Woman? Tell Me So, as well as his own instrumental flourishes, and kept it at the ready for the right moment and the right artist until I got the call from B. He later said, as the single that inaugurated this particular singer's solo career, the song emphatically announced her arrival as the era's dominant pop power. This other person who collaborated with her, Killer Verse, was added at the last minute, and this particular artist and her collaborator had just started dating at the time, and the song's lyrics and head over heels delivery reflected what she described as the first step of a relationship right before you let go. Who was it? What's the song? I hear Alan typing. What's he going to come up with? That's right, Alan.
Oh, yeah. Rosie rings me, and I get a string of ones that I actually knew the damn answer to.
It's Beyonce and Jay-Z. What is the song?
Hey, Rosie's not ringing you to tell you the answers, and she's watching us live.
No, she completely forgets that it's Wednesday streaming.
Anyone know what the song is? No? Something in Love. You're right there, Carl Edwards. What is that C word? No one seems to know. Okay, I'll give it to you. It is Beyonce featuring Jay-Z, Crazy in Love. Okay. Number 15. In 1963, the Somethings gave themselves an ultimatum. We're not going to America till we've got a #1 record, this particular person declared. So he and another particular person in the band went to the home of the parents of Jane Asher, some person's girlfriend, where one-on-one, eyeball to eyeball, as this other person later put it, they wrote this particular song. An irresistibly erotic come-on framed as a chaste, bashful request. Okay, I think Alan might have it. The lightning bolt energy after their collaboration ran through the band's performance. Rush released in America the day after Christmas, and this particular song hit #1 in the States on February the 1st, 1964. And you're right out in the peanuts, and as well as that, Alan.
I didn't want to type all the answer out.
Yeah, it is the Beatles with I Want to Hold Your Hand.
Yeah, I was typing that.
Yeah. Number 14. After this band first burst of British invasion pop success fizzled, Ray Davies really needed to write another hit, but instead he wrote this song. It's a delicate guitar ballad about a solitary man who watches the world from his window, gazing on a couple of lovers who meet at a dismal London train station. For Davies, it was so personal, he didn't even dare show the lyrics to the other band members until he recorded his vocal. As he said, it was like an extract from a diary nobody was allowed to read, yet it became his most beloved creation. You never know from the song what a dumb something or other is. A tribute to Davies' power to find beauty in the mundane. Who was the band? What was the song?
Only band I can think.
Right band, Alan. Wrong song.
Yeah, it's that one, isn't it?
It is. That is the one. Yeah, not Waterloo Subway. Waterloo Sunset. Yes. All right.
Well, I had the right
Peanuts
band.
Were all over.
I wouldn't have got the song.
Yep. Okay, number 13. The Something channeled the emotional wreckage of the late 60s on a song that this particular person wrote in 20 minutes. The intro, strummed on an electric acoustic guitar, modelled on a Chuck Berry's favourite, conjures an unparalleled aura of dread. The singer, Mary Clayton, brings down Armageddon with a soul-racked wail. Rape, murder, it's just a shot away. The song surfaced days after Meredith Hunter's murder at the Ultimate Music Festival. That's a kind of end-of-the-world song, really, this particular person said in 1995. It's apocalypse. Later said that his guitar fell apart on the last take, as if by design. Anyone know who the artist is and what the song is? Ooh. I think we've got one part of the clue out there solved with Carl Edwards, who has identified that the KR stands for Keith Richards. That means the MJ probably stands for... Come on, let's hear it. Mick Jagger. What's the song? Anyone know? No, we seem to be drawing blanks on this one. It was the Rolling Stones with Gimme Shelter, which I think actually somebody got out there. Who was it? It was Vroom Fondle who got it way back there. Very well done, Vroom Fondle. Okay, number 12. This particular artist debuted his hard blast of funk live while opening for the Rolling Stones in the summer of 1972. Intent on expanding his audience, the 22-year-old former child star had written it in a drum set, humming the other parts to himself. So-and-so had initially intended for Jeff Beck to record the song, but Berry Gordy wouldn't let him give it away. It became the first single from this particular person and somebody else's first number one hit in nearly a decade. A lot of people, especially black folks, let superstition rule their lives. But this person said, "This is crazy. The worst thing is, the more you believe in it, the more bad things happen to you." Who was the artist and what was the song? Clive Wells says, "Sleeping Warrior." I don't think so. No. You are correct, Alan, and that is the correct artist. The Peanuts beat you to it, though, with
I know.
Stevie Wonder.
I did see it. I saw it in the side chat before I had a chance to type it up. But I did know.
Yeah.
But I didn't know.
And,
but I didn't know the name of the song, which is why I didn't cheat and add that in.
And it's well done to the Peanuts. It's Stevie Wonder with Superstition. Number 11. It's very emotional. Always a bit of a choker with me, said this particular person of this Pet Sounds ballad. The night this particular person and another particular person, who would be John Lennon, obviously, because I forgot to take out one of those, first heard Pet Sounds at a London party. They wrote Here, There and Everywhere, which is influenced by this particular song. Carl Wilson's underrated lead vocal is note perfect, but it's the arrangement of horns, sleigh bells, strings, and accordion that gives this particular song its heavenly feel. Brian Wilson was fascinated by the spirituality and said this song came out of prayer sessions in the studio. We made it a religious ceremony, he said, of recording Pet Sounds. The only problem, the use of the word in the title scared off some radio programmers. What was the song and who was the group? Yes, one of the people is Paul McCartney. Blue, well done. It's not Got Over Kringle.
I think I
yes,
see who.
And one
I
of
think
the words.
I see.
One
I
of the.
I think I see who.
Terry.
Yeah, I was just going to say. I think I can see who got it right out there.
Yes, Clive Wells. You thinking?
Yeah.
It is. It's Clive Wells who's got it right. It's actually the Beach Boys. God only knows. Yeah. Okay. Number 10. About as radical as fun can get. This particular song is funk, pop, rap and rock spun into something otherworldly yet immediately lovable via this person's one-of-a-kind Stankonian vision. Andre 3000 began writing the song on acoustic guitar, bashing out some chords that he wanted to sound like the Smiths and the Buzzcocks. He had the bulk of it already conceptualized in his head, said the recording engineer John Fry. It all happened quite fast. We recorded the skeleton part with the intro and the first verse and hook all in one night. Anyone know who it is yet? Wow. Yeah. They know what the song is.
Yeah.
Who knows what the band is? I haven't seen the band title yet. You're right. The song title is Hey Ya. Who knows what the band is?
That starts with an O, doesn't it?
It does start with an O, yeah. And there you go. Fred Knotts has it. It's Outcast. Outcast with Hey Ya.
No.
Number 9.
I think Fred Bailey might have an awful lot of delay on his stream.
What Waterloo Station? Where's he get that from?
I think that's a while back.
Fred, you got to catch up.
Yeah. In the face of a lover telling her to go her own way, this particular singer penned the ethereal this particular song during this particular sessions in Sausalito, California. That should be enough to tell you what the song and the artist is. This particular artist spent an off day in another room of the record plant that was supposedly used by Sly and the Family Stone. It was a black and red room with sunken pit in the middle where there was a piano and a big black velvet bed with Victorian drapes, she told Blender. There she reflected on the thunder and rain of her relationship with this particular person who was another band member, whose guitar parts sliced through the song's mystical beat. I sat down on the bed with my keyboard in front of me, found a drum pattern, switched on my little cassette player on, and wrote this particular song in about 10 minutes. Anyone know who it is yet? Vroomfondle. That's correct, but that's not what the song is called. That's not the name of the song. It's the right song, but that's not the title. You're right, it is Fleetwood Mac, and it's Stevie Nicks who wrote and sang this song. Do you know what the song is called? You're right, it has the words "you can go your own way" in it repeatedly, but that's not what the song's called. No? Okay, it was Fleetwood Mac with Dreams. Counting down to number 8. Oh yeah, man. We was on some futuristic stuff for sure, this particular person said. He told Rolling Stone in 2020. On her musical chemistry with this particular person. It was something hypnotic about those records, this particular person. And another one took over the radio in the late 90s. Just two kids out of Portsmouth, Virginia, blowing minds with their own unique space funk sound. She didn't obey any of the rules for female stars at the time, and her music didn't obey rules either. Nobody could duplicate the combination of these two mojo. This particular song is the peak of their long-running collaboration, a massively weird avant-garde experiment that also blew up into a global pop hit. Anyone know yet? Not the Crazy Frog. I like to move it. No, that's not the right one.
Well, hi everyone.
Oops, sorry.
Well, hi there. Yeah.
That was Bob.
Yeah. Even by their standards, this particular song was crazed challenge to the audience, with this particular person yelling "Holla!" over a warped Bangra loop. As she once recalled, I was like, this particular person, you sure this isn't too far left for that people won't go and get it? It sounds like some Japanese stuff mixed with a hip-hop beat. Anyone know who this is yet? No, this is a hard one. But everybody who heard it was hooked. The whole world wanted to holler along with Miss E. This particular song remains an anthem for freaks everywhere, and even after 20 years it still sounds like the future. Anyone know what the song is? Or the artist? No, I'll give you a picture. That's the actual artist. Anyone know who that is? You are right, Fred Knotts. It is Missy Elliott. Do you know what the song is? We'll just wait for the peanuts for a moment to catch up. That is correct, Fred Knotts. Well done. It is Missy Elliott with Get Your Freak On. Number 7. This particular artist, who's featured quite a lot in this, was one of the world's most visible people in 1966. But he wrote his most exquisitely lonely song with this particular person. It opened up a whole new psychedelic era for the band, changing the way pop music was heard and made. But it began with this particular person, alone on a Spanish beach with an acoustic guitar, writing a song about his painful childhood memories. This particular song was the name of a Liverpool orphanage where he used to play and hide from the world as a boy. I have visions of this particular place, he told Rolling Stones in 1958, because this particular place is anywhere you want to go. I think Alan knows what it is.
Well, apart from the...
that is correct. Apart from the spelling mistake, I know what you mean,
spelling
Alan.
mistake.
Yeah. And well done to Vroomfondle with Beatles and Strawberry Fields Forever. That is the correct song. Yes. Down to number 6. This particular song is an exquisite plea for peace on earth, sung by a man at the height of crisis. In 1970, this particular person was Motown's top male vocal star, yet he was frustrated by the assembly line role he played on his own hits, devastated by the loss of duet partner Tammy Terrell, who died that March after a 3-year battle with a brain tumour. This particular person was also trapped in a turbulent marriage to Anna Gordy, Motown boss Berry Gordy's sister. This particular person was tormented too by his relationship with his puritanical father. Anyone know who it is yet? That is the correct artist, John. Not quite spelled correctly with the surname there. It's got an E on the end. But yes, that is the person. And that, you're right, Fred Knotts, that is the person. Anyone know what the song is? Initially, we'll go right down to the bottom then. Initially rejected as uncommercial, this particular song, with background vocals by 2 players from the Detroit Lions, was Marvin Gaye's finest studio achievement, a timeless gift of healing. Anyone know what the song is? You're right, Fred Knotts. Well done. Fred's on fire today. It is Marvin Gaye with What's Going On. Number 5, producer Butch Vig first heard this particular song in early 1991 in a boombox cassette recorded by bassist Chris Novoselic, drummer Dave Goll, and singer-guitarist-songwriter this particular person. In a barn in Tacoma, Washington, the fidelity was abysmal. Vig, about to work with this particular band on their major label debut, could not tell that the song would soon make underground Seattle rock the new mainstream and catapult this particular person, a troubled young man with strict indie culture ethics, into mega celebrity. Anyone know who it is yet?
No.
No. I could sort of hear the hello, hello part of the chords, Vig said years later, but it was so indecipherable that I've had no idea what to expect. Okay, this particular album or song was this particular person's attempt to write the ultimate pop song, he said, using the soft, loud dynamic of his favourite band, the Pixies. The insidious hooks also showed his admiration for John Lennon. This particular person had that dichotomy of punk rage and alienation, Vig said, but also this vulnerable pop sensibility. In this particular song, a lot of that vulnerability is in the tone of his voice. Who is it? Anyone know? Oh, yes, and we have an answer out in the peanuts. Well done to Clive Wells with Nirvana. Sounds like Teen Spirit. Well done. All right, number 4.
I wouldn't have got that one.
Nearly there. Only 4 more to go. I wrote it. I didn't fail. It was straight, said this particular person. Said of his greatest song shortly after he recorded it in June 1965. There is no better description of this particular song, of its revolutionary design and execution, or of the young man just turned 24 who created it. That's correct. That's the artist. Well done, gosh. Big Blue and Alan. Do you know what the song is? Yeah. I'll go down a bit further in it. I like this part where he says, before going to Columbia Records, New York studios, to cut it, this particular person summoned Mike Bloomfield, the guitarist in the Paul Butterfield Blues Band, to Woodstock to learn the song. He said, I don't want you to play any of that BB King shit. None of that fucking blues. Pardon the language. Recalled Bloomfield, who died in 1981. I want you to play something else. Okay. So you've got the right artist, folks. It is Bob Dylan. Who knows what the song is? And yes, RT96 has it out there. Blowing in the Wind. Rolling Stone. No, sorry, it was Like a Rolling Stone. Sorry. Like a Rolling Stone. RT96. Yeah, Like a Rolling Stone. Sorry. I don't know why I read that. I read Alan's thing, but it's not.
Yeah. Well, yeah. I mean, that's the song that always comes to my mind when I think of Bob Dylan. So there you go.
Yeah. Okay, number 3. In 1963, this particular person, America's first great soul singer and one of the most successful pop acts in the nation, with 18 top 30 hits since 1957, heard a song that profoundly inspired and disturbed him, Bob Dylan's Blowin' in the Wind. Yeah, there you go. What struck this particular person was the challenge implicit in Dylan's anthem. Geez, this person mused. A white boy writing a song like that? This particular person's response, and this is his song, recorded on January 30th, 1964, with a sumptuous orchestral arrangement by Renee Hall, was more personal in its first-person language and the experiences that preceded its creation. Anyone know who it is yet? No? Okay. On October the 8th, 1963, while on tour, this particular person and members of his entourage were arrested in Steveport, Louisiana, for disturbing the peace after they tried to register at a white hotel. An incident reflected in the song's third verse, and this particular person's mourning for his 18-month-old son, Vincent, who drowned that June, resonates in the last verse. There have been times that I thought I couldn't last for long. On December the 11th, 1964, almost a year after he recorded it, this particular person was fatally shot at an LA motel. 2 weeks later, this particular song was released, becoming his farewell address and an anthem of the civil rights movement. Anyone know who it is? Yes, Dave Cannabis knows that it is Sam Cooke. Anyone know what the song is?
Never heard of that bloke.
You've never heard of him, Terry? Well, there you go. You're getting a musical education tonight. Yeah.
I've definitely heard of him, but I can't. I'm sure I've heard of several of his tracks, but
yeah, I'd have to listen to something that he sang that was well known to maybe see if I
know
it.
Tons of stuff that was well known.
The song was A Change Is Gonna Come. There you go. Sam Cooke with A Change Is Gonna Come. Number 2. Chuck D once likened this particular song to Pete Seeger singing We Shall Overcome. This particular song, he said, points to the legacy of the strengths of standing up in music. Filmmaker Spike Lee had originally asked this particular person to write an anthem for the Do the Right Thing, a movie about confronting white supremacy. So Chuck and the group's producers, the Bomb Squad, took inspiration from the Isley Brothers' funky this song and used the title as a blueprint for a whole new war cry. In just under 5 minutes of scuzzy break beats and clarion call horn samples, Chuck D and his foil Flavor Flav, present a manifesto for racial revolution and black pride, with cones like "Our freedom of speech is freedom of death," and rallying cries to rethink the basics of American life itself in lines like "Most of my heroes don't appear on no stamps." Anyone know who this is? I would have given audio clues, but that probably would have stopped Terry's stream.
Yeah, no, I don't want that.
Yeah.
No.
Yeah. I was aware of that, Terry.
Yeah.
Yeah.
Sorry,
the song was exactly what Lee's movie needed, so it was played over and over again anytime the character Radio Raheem showed up with his boombox, making it an instant classic. I think it was this particular person's and Spike Lee's defining moment, because it had awoken the black community to a revolution that was akin to the 60s revolution, where you had Martin Luther King or Malcolm X. The Bomb Squad's Hawk Shockley once said it made the entire hip-hop community recognize its power. Then the real revolution began. Who is the band and what is the song? Wow! Zebulon 181 has the band. It is Public Enemy. And I like Dave Cannabis's guess. Fuck the police.
Yeah, to fit all the letters in.
It doesn't quite fit.
No.
Yeah. Well done, 303DB, who is not blue, out in the chat. Welcome. Public Enemy, Fight the Power. Well done.
Dave, if you put an S on the end of that first word, you might have fitted it in.
Yeah. I'm not going to read all of this one, but this is
no.
one. Okay. All right. When this particular person left Columbia Records for Atlantic in 1966, the label's vice president, Jerry Wexler, came to the singer with some suggestions for songs she might cover, like Sam Cooke's A Change Is Gonna Come and Ray Charles' Drown in My Own Tears. She liked those ideas, but she had one of her own, and this particular song starting with an R. A song she'd been performing live. Long as she changes it up, Wexler told this particular person's manager, Ted White, in an exchange recounted by this particular person's biographer, David Ritz. You don't got to worry about that, White responded. She changes it up, all right. Anyone know? Yes, we have the correct artist out there and the correct song.
I was about to get
Aretha
to the
Franklin.
song, if I could.
Yeah, it is Aretha Franklin, With Respect.
I probably would have got there eventually.
Yeah, that's the artist, and there you go, Aretha Franklin, With Respect. So,
I took
well done,
I
all
spelt
you.
Franklin right, but I kept mucking up the first.
Yeah.
Yeah.
Now that was a bit of a longer quiz. I'll make the quiz shorter next time. And shall we have a science quiz again next week? You want a science quiz
with
again?
some easier questions that maybe I can answer.
Okay. All right. I will do that then. Okay.
Is that why you're still naked, Mr. 303DB? Well, as long as you've subbed, that's the main thing. That's the only thing I like to know is if you subbed. If you subbed, you can have a spanner.
There you go. That was your quiz for tonight. Bit of a different one. It was a hard one though.
Interesting insight into Paul's record collection. Fred's trying to sing out there. You're supposed to put the little minus thing next to the R and E to make it that, so you spell it out.
I'm waiting for my new set of speakers to come. So, that'll be great when I get those.
For that 20-meter size screen TV you got.
Oh no, I've got a different set of speakers coming for that, but I'm waiting for a set of speakers for my music room that I'm going to put in there. I'm getting a set of secondhand Klipsch La Scala AL5s.
Yeah, I've got a big set of speakers here that I've never used. They're old though. 2 years you've been subbed 303DB.
Yeah.
Wow.
Well, unfortunately, if you never type in the side chat, you're never going to get spannered, are you?
Yeah, they could be subbed all that time, and they never get a spanner. Then you go, where'd that person come from?
Well, you can't give them a spanner until they type something.
Yeah, exactly.
That's right. Yeah.
Oh, bugger.
But you soon lose your spanner. You never know.
Yep, God giveth, but Terry taketh away.
Oh dear.
I've got a few videos, but it looks like Blue didn't do any lately that I know of.
I didn't do any. No. Nope.
I think I'd done you last Saturday.
You did?
Yeah.
Wally's got one.
Yeah, I've got Wally sorted because I did the thumbnail, if anyone remembers what was on the thumbnail for the stream. That was meant to be the theme for tonight, but we didn't quite get there. But I'll play Wally's videos for that. Pardon?
Dora's taking chances with you, mate.
You never know that Terry is... It's what? 303 DB is Lindsay's sock account. That'd be a surprise. Fred just lost his spanner. Fred, you've just lost your spanner. You said the W word.
The W word?
Yeah,
yes.
Wrench.
The W word.
Oh, God, even worse than using the F word.
Yeah. So, Peanuts, vote if Fred should lose his spanner or get timed out. Which one? What punishment deserves that?
Well, you've got to look at it in combination, because not only did he use the wrong word describing the tool, but he also used that
the other
word.
The F word.
Yeah.
Dora's going. Look, you're pushing it now. Dora's getting in on it, and I just asked you, what's the punishment? And then
stoning.
Oh, that's it. That's it. Look,
yeah,
I've had enough of you peanuts. That's it.
Time the entire peanuts.
Yeah, I'm gonna time you all out. That's it. Everyone gets timed out. The whole lot. There we go. Who else? Who's left? Time out. Well, I can either take their spanners off them and they can just time each other out. Right. Now, where was I up to? Right, now, back to what I was saying. The thumbnail had something to do with what you use in navigation. And it seems to have been the hot topic in the last, at least the last few weeks. And the only contention I've heard about it, that it proves a flat Earth for some reason. Because you have to aim it to the horizon. But then another one I heard is it makes a triangle because of your see, I'm trying to learn these things and now I'll forget it.
That's the problem with it. Yeah, it doesn't make the triangle that they draw.
Yeah.
No, it doesn't. It definitely doesn't.
When you draw the damn picture wrong, yes, you can make it look wrong. But
yeah. Did I get a picture for that or did I lose that one? I try to collect these things. Did I? And I haven't got it set up to draw things to be able to draw it real quick to say, okay, this is how where they're wrong and this is how what they're getting wrong. But I don't think
if you happen to find yourself standing within about 3 nautical miles of the GP, yeah, you may be able to draw that triangle.
No, I didn't take
That's the only way.
No, it looks like I didn't get a screenshot of it from over on the derp channels. I think I missed out on that one. I usually grab pictures. There was only a basic drawing.
60 degrees.
It was a basic drawing that they were getting wrong, and I should have took a picture of it. I don't think I did.
Is this to do with right angle is 60 degrees? Right angles are acute.
No.
2021.
No.
Has any Peanuts got a screenshot of that picture? Because there was a few of them out that had been put out in Discord. I remember in Gems or in Geo's channel, or in I don't know who else. No, I don't think I've.
They seem to have suddenly been confused about the relationship between perpendicular and horizontal, don't they, Blue?
Yeah.
They don't seem to be able to comprehend all of a sudden just how you relate the two of them together. That if you have one, you automatically have the other.
Geez, I failed miserably this time for that. I had half a plan. Just missed out on the other bit. It's easier to describe it with the picture, which I haven't got. And I don't think I can draw a picture straight away and share the screen. I haven't got that able to set up that. The image would have been better than one they kept getting wrong. And the curved surface of the Earth part, they said you can't have the curve for the triangle or something as well, for the points.
That's because they don't know what triangle, or if you even need a triangle.
There is no. You don't need a triangle.
You don't need a triangle. It's not a.
You're not.
Yeah.
You're not making triangles. You're measuring angles.
Yeah.
Yeah. That's
right.
What
I kept. That's what I did. I did learn about that part of it. Yeah. But what's the triangle got to do with it?
Nothing.
Oh, I do have an image here that if you can explain it better than what I could, but I did capture this image, which is probably similar to what we're talking about. Okay.
It's all this falderall that they come up with about a curved baseline, about a baseline.
Yeah.
They're yammering on and on constantly about a baseline, which is absolute crap. There is they try to represent it as if you're making a triangle, and you are not. You're measuring the angle from your local horizontal, which would be a tangent line to the surface of the Earth where you're standing. That the angle from that line to the celestial object. That's the angle that you're trying to measure. It in no way implies that that line is connecting to a point at the GP of the celestial object. That's a false line that they shoehorn in there. Yeah. The fact of the matter is, the only way you could do that is to be within a very few miles of the GP of the celestial object, which would make it useless to you in the first place.
You'll like this image that I found. I couldn't find. Is it showing up, or is it too big? I can make it smaller.
Oh, it's showing up.
I don't know if I could make it any smaller.
Good.
Well, it's close enough. It shows the equator anyway, at least to there. It didn't go any further past the equator, the picture.
Well, yeah, it just implies that what you would actually see if it was like that.
I wanted to try to do a comparison with it to the actual globe, what it would be comparable to, if there was a way to do it. Because it's got the latitudes on the flat Earth written down, but the apparent altitude of Polaris that would be seen on a flat Earth, so that's not very high. What, 4,969 kilometres?
Yeah, 3,100 miles.
That's not that far off from the sun or the dome, whatever.
But actually, that distance only works for one. I'm going to guess that works for the 45 degrees because that's why 45 degrees is in green.
Yeah, that's the only place it works. You go either side of 45 degrees and the angles are wrong.
Or the altitude changes.
Yep.
Or the altitude changes, correct.
Oh, okay then, Dora. I think I'll forgive you this time. Oh, Rumpus, we need a diagram now. Hey, you got a job to do, Rumpus. Is he gone to sleep?
Well, it's the middle of the day. You might have had to nip off to do something.
Oh, okay. I'm sure we could have raped him into doing it.
I'm sure he's probably got the diagram you need to hand.
Okay, we'll put that on hold.
Hello. Did someone call me?
Called you?
Yes, we did.
Yeah, we're talking about you, not to you.
All right. A diagram or something.
I don't know.
What
was I saying, everyone?
Terry would like the globe equivalent of the diagram that is currently on display.
Yeah, it's to do with the sextant to the Polaris topic which is what my thumbnail started off with.
Oh, you want using a sextant? Okay.
Yeah, because how the Flurfus were getting the sextant angles and calling it a triangle, and the third line that's got to be from the vertical.
Give me a sec.
I was getting a headache, that topic, for the last couple of weeks.
I can't share a screen while you're sharing it, apparently.
Oh, yeah. Oh, sorry. There you go. The stream's yours on the screen.
Okay. Now where is my...
I thought somebody might have had it already done. I looked for one. I couldn't find one. I'd like to put them side by side.
Here we go. Right. So, yeah. So there's a... So is this what you want?
Well, we've got the latitudes as well for the globe and what the angles would be.
So are you trying to show what the sextant does, or are you trying to talk about Polaris?
Well, this is what a selection shows with the angles to Polaris, and then it shows you your latitudes on a globe. But I've got the flat Earth image here that I was trying to get an equivalence to the globe to show why that's wrong on a flat Earth.
But that's just a thing to Polaris. That's that you were showing, whereas you're talking about the sextant, which is slightly different.
What you're not using a sextant to
well, I mean, you can, if you want about the... Well, I mean, obviously you've got on a flat Earth. There's your attitude to Polaris, and obviously on a globe Earth.
Yeah, that's what I've got here. Then what you've got just there.
Okay, and then on globe Earth. Right, so the globe Earth, if you're just looking at Polaris, then the angles to Polaris obviously follow this rule, whereas on a flat Earth, they follow that rule. And then you get a graph, and if you draw a graph, this is what the angle to Polaris looks like on a flat Earth. Given your assuming a height, this is assuming a height of what am I assuming? 5,000 kilometers.
Okay.
So if you assume a height of Polaris is 5,000 kilometers, obviously that can't change, although we had that changing. I think Glean did a demo once, presentation in which he had the height of Polaris changing. But if you assume a height of 5,000, which of course is what the Eratosthenes experiment, if you assume that the Earth is flat and you have one observation, then you end up with a height of about 5,000 kilometers. And so this is what would happen if you then moved. If you take a degree, as we accepted, is of 69 miles per degree. So along the bottom here, I've got the distance south from the North Pole in kilometers. And there we have the angle you would have to Polaris. This is the graph that you would get, which is just simply arctan of 5,000. Yeah, it's just simple case of this triangle. Obviously, if this presentation I had to do this. Sorry?
It's literally using an arbitrary distance, right? Like if you
well, it's not arbitrary.
Well, it sounds like
if you do the Eratosthenes thing, then
right, it would be. It's absolutely arbitrary, like of how far away stars are. Oh, are you live? Okay. I don't know. I don't know what Zoom is. Oh, is there a link to it somewhere? Maybe. Sure.
There you go. Sorry, Rumpus.
That's okay. Did you see George just, Paul, disappear into his image? I don't quite understand how he managed to make
well,
it.
he's got the virtual background, and the lighting's hitting you on a certain angle. If you move, you disappear into the image.
Well, he went through a door, but so he hasn't got a green screen then behind him. He's got...
No. It's in Zoom, you can have a virtual background.
Oh, right. Oh, I see.
And it's actually really good at green screening you in if you've got. It is. Yeah. But of course, the minute you get up and walk away, you just disappear.
Yeah.
Well, he didn't. The odd thing was he disappeared. He got smaller, and then he opened the door, and so and then he disappeared through this door. But the background sort of went on the door, and then he gradually hid away. And then obviously when he closed it, so I don't understand how it worked out what was a door and what was him.
They've got a really good thing on Discord as well for it as well nowadays as well. Because I thought that somebody had bought a green screen, and it turned out that they hadn't. They just like melded their background into whatever they wanted to show. Yeah.
Right. So did you want me to go ahead, Terry? With
yes,
what I was
please.
talking about,
Yes, please.
All right. Right. So we end up you get this thing of 5,000 kilometers height, because if you take the Aristophanes experiment and you assume the Earth is flat, then so if you simply, so in other words, if you assume the Aristophanes thing is as someone mentioned, this is at 5,000, and you say you've got an angle of 45 degrees, which is, then you end up with a height of 5,000 for the height of the. So if you know you're from the North Pole, when you know the Polaris is above the North Pole, and you're 5,000 kilometers from it, and you then decide, right, okay, if I know I'm 5,000 and it's directly above Polaris, then you know that must be 5,000. So it's not arbitrary, the measurement of where Polaris is. It's something that the Aristophanes type experiment, if you're assuming it's got to be at that height. So then what does it then do at other distances? So if you take your, where it's 45 degrees as I'm going to make that decide that's going to be the thing that decides where Polaris is. Well, then this is what's going to happen to it. Now, obviously, what you could do is, if you did different measurements, as I think Alan said, if you decided to make Polaris and you went to the equator, and you said, well, I'm 10,000 from the equator, and Polaris was 45 degrees. Well, no, it's not going to be that. Yes, the point is at 45 degrees, it's a 45 degrees when it's at 0. But you've got to pick on. So if you decide to pick on some value from Polaris based upon some knowledge of where you are and the angle to it, because here's the graph of. Well, yes, I suppose I'm fixing its height based upon the 45 degrees. But this is what it would do if that was the case. If you take your 45 degrees one, this is what the angle to Polaris should follow. When you get down to 20,000 kilometers, which is, so the equator's at 10,000, so you'd expect to see at 10,000 the angle to Polaris to be 26.5, and by the time you got to the South Pole at 20,000, then it should be about something underneath 20, about 18. So that's the shape it should follow on a flat Earth. But of course, and this, and also this is tells you what the distance would be to move a 1 degree change. So in other words, at the equator, this is the distance on the left-hand side that would constitute 1 degree. Now, so we'll talk about 169 miles, 69 statute miles for being 1 degree. Well, that's 100. This is in kilometers, so it's 111. So that's about here. But this is how much on the flat Earth that 1 degree should change by. So at London, 4,280 kilometers from the North Pole, it should be 151 kilometers to get a 1 degree change, whereas we know it's actually 111 everywhere. So this line here represents what 1 degree would be for each of the different distances from the equator, and matches latitude. And then you can put them over together. And this is then the Earth one, where this is the relationship you get for the angle and the distance. And as you can see at 10,000, the angle to Polaris becomes 0, and at London here at 4,280, it is 51.5. And if you put the two together, and this is how far 1 degree changes at these different latitudes, and it remains at 111 for all latitudes. So no matter where you are, obviously off to the equator you can't actually see the Polaris, but for all the time you can in the northern hemisphere you can see it. 1 degree, Polaris moved by 1 degree for every 111 kilometers. So here's the this is the distance delta S you have to travel to get 1 degree change, and this is then putting over to get, and this puts it together. So this is the globe Earth model and the flat Earth model together. So here we have, this is for the angle to Polaris. So this is what the flat Earth model does, and this is what the one I showed you before, what the globe Earth model does. And you can see they actually agree at 45 degrees as to what the angle to Polaris would be, and they also agree at Polaris, sorry, at 0 degrees actually. But those are the only two places. And here, this line here, this is the difference between them. So they agree at Polaris. At the Arctic Circle, they are 4 degrees different, and then when they get to London, the difference in the angle to Polaris is minus 2.1 degrees, and they agree again at 5,000, which is on the 0. That's at 45 degrees. So they agree only at 0 and 45. So hit that green line here, the black line, is the error, the difference between the two. And then obviously at the equator, we've got a huge difference. This is so this green line here reaches 26.5 degrees, because obviously for the spherical Earth, it's 0, and for the flat Earth, it's 26.5, and therefore the error is also 26.5. So this green line here is the difference between the two models. And of course, the key thing is that what we observe is the orange line. And so, what else have I got here? There's also the difference between again, the difference in degrees. So for the flat Earth, as I was showing you earlier, this is the angle you would have to move to get 1 degree change. On the spherical Earth, it's constant, and on this is the angle, comparing the two together, of what the distance you'd have to travel to get a 1 degree change. I haven't quite finished the rest. I finished.
You had a diagram up above that demonstrates the issue that they create. Go up a little further. Whoa, right there. No, down some. Down, down, down. One more. One more. That right there. That diagram right there. That shows the problem. That flat earthers create. They try to maintain it for some reason or the other. We need that red line when we're measuring our angles with a sextant, which is the massive error they make to begin with. They claim that you can't. The sextant won't work on a spherical Earth because you don't have they call it a flat baseline, a line between your point of observation and the GP. We don't use that. We use the local, diagram. We use that local horizontal. And you don't even need that. If you've got a bubble sextant, you just take it off of off vertical.
Yes, I mean, the way a sextant works is, let's imagine a sextant in the top of this ship here. What angle are you going to measure with a sextant? Well, the only things you can see are the thing you're looking at, the celestial body, star, and the horizon. Those are the only two things that you can clearly identify. And so that means you measure angle A here, which is the, and as you can see, that dips down. It's not, but what you want, of course, is the horizontal.
Right.
You want, because that's the only thing that, because from the horizontal, because we know there's this relationship between, certainly Polaris, I mean, this is a bit more complicated because it's not Polaris, that your latitude is equal to your angle to Polaris. So this is sort of a bit more complicated. This is to an arbitrary celestial body. And so obviously you don't, and there's nothing about a triangle in here, as Blue was just saying. You just simply want to measure this angle A, which is just to measure the difference, the angular size from the horizon to the celestial body, and that's angle A. And then you from the tables inside a nautical almanac, you then get angle C. So you've measured A, which is called the altitude, and this is another thing they get wrong, of course, because the altitude, you see these sites that talk about elevation being altitude. There's not. I mean, they talk about the elevation to something as being from the horizontal, but those are usually. I mean, elevation is used, unfortunately, in multiple ways. But it's a not terribly well defined term. But the sextants, obviously, they make it exact, and they call this angle to the horizon the altitude A. Now, if you want to get the angle to the celestial body, which is B, above the horizontal, you need to subtract C, which is the dip angle. And so from the height of your observer on your ship, you then, assuming standard refraction, you then know what C is. That's so having known what C from the nautical almanac is, subtract that from A, and you end up with B. So you now know, and yes, as Blue was saying, all this rubbish about how you can obviously measure angle to the horizon without no triangle involved here. And this doesn't matter what this is curved, it doesn't matter if this is wiggly shaped, it doesn't matter if it's banana shaped. Providing the horizon is the thing you can pin on, it doesn't matter what the intervening shape of this stuff in between you, the ship, and the horizon is, providing the horizon reflects the surface of the Earth. Doesn't matter what the hell's going on here. There could be a big hole here as far as you're concerned, or a big mountain provided it doesn't cross over.
Well, again, angle C takes into account two things. It takes into account your height above the surface and refraction, standard refraction. Excellent. It takes those two things into account. And when you subtract those from your measured angle, your raw angle, angle A that you measured there, then you get the actual angle to the celestial body.
From the horizontal.
Now, from horizontal. Yeah, from a horizontal. But again, you don't even need that. If you want to use a bubble sextant, that thing looks at the zenith. Then you have no dip angle to worry about. You don't have to worry about any of this.
Correct. So so the only reason, so in other words, it's, I mean, you might sound a bit, I mean, when you first think about it, why you want the angle to the horizontal, and you think, well, why the hell are they messing around with the only thing used for the horizon is to find out what this C is. Well, sorry, to give you it's the dip angle business. I mean, you think it would be, as Blue says, I was a bit surprised to think they hadn't thought earlier of using some sort of bubble horizontal something or other to measure it, or even a plumb bob or something. You could, there are all sorts of ways of working your local horizontal and vertical.
Well, I think it's just much harder to do that on a rocking ship. If you're trying to hold a zenith angle. But
then but you'd have thought working out the horizon was just as difficult. If it's wiggling up and down, isn't it just as tricky to keep your thing on the horizon as it is to cope with a dangling pendulum?
I really can't answer that.
I suppose on an aeroplane it's not so bad. I mean, presumably when they have those bubble things inside an aeroplane, the aerial sextants, where they do they can't see the horizon, so they have to use a bubble thing. I presume they're a bit more stable. I mean, an airplane can go along a bit more. I mean, you know about this. You can have phases when the airplane's behaving itself, presumably to be reasonably stable. You can use some things like bubbles and things where it's okay.
Absolutely.
Yeah. So if you're in an aeroplane, then you don't need any of this horizon stuff. You can just have a bubble thing or equivalent of a plumb bob, but obviously much easier to use a bubble thing than that. But that's all this is. All this is trying to do is what you want is relevant to the horizontal, because you obviously want a tangent to the Earth's surface, and then you end up with B. Once you're in B, well, then you're, as they say, cooking on gas, because then you've got you then can start doing calculations about where this star is, and then the tables, of course, give you the in the nautical table they give you the angle of the star relative to a point above them on the celestial sphere, which is relative to the axis of the Earth. And then you need to know, obviously, from the horizontal, you know, once you know where that is and your relation to horizontal to the axis of the Earth, then you can which is effectively what B is. If you know what this is, if you know what this, if this is at the North Pole, then obviously B would then be your latitude. And if you then know that this is supposed to be at, I don't know, 60 degrees, and you got this angle to it, and you know it should be 60 degrees if you're at the North Pole, you then can work out your latitude from that. So it's actually quite moderately complicated, actually, the final bits and bobs. But the key thing is, once you've got an angle from the horizontal, then you've got all the information you need to know, because then you can start, the tables can then start telling you what angle you should see if you know what your horizontal angle is. And as none of this involves a triangle, there's no triangulation. It's all just to do with angles. So this obsession they've got with this having an angle, and also they then claim, of course, you can't have an angle to a curve, which is obviously complete rubbish. I mean, I've got another. Here we are, for instance. They claim you can't do this. This is a tangent here. I mean, basically, they're denying that tangents work. I mean, QE did it last night. He was saying that you can't have an angle to a curve. You can't. Well, hold on. What's this tangent here? So I zoom in. So there's the circle. Zoom in, and there we have it. You cannot distinguish the tangent from the curve itself. They become one and the same. If you zoom in infinitely, you would have the same. And once you've got the same angle, well, obviously 90 degrees to that then gives you a zenith effectively to that. So you can have any angle you like to a curve, because due to infinitesimals, they become a straight line. They might become infinitesimally small, but they still have a gradient. They still have a gradient. If you've got something with a gradient, the only thing a line needs to be, the only definition you need for a line is its gradient and its offset from some coordinate system. But as you don't care about the constant on the graph, you only care about the gradient. That's all you need. You've done it. And you can extend that line, because people like Bev say, how can you extend a line from a point? Well, if you've got a gradient, you've done the job. You have the gradient. And if you've got a gradient, you can do 90 degrees to that, and off you go. So this idea you can't get angles to curves is just absolutely insane. I mean, how you can even think that with one Google of that, we're telling tangents. What do they think a tangent is, for Christ's sake? Yeah, once you've got an angle to your where's it gone? Tangent. Where's my bloody not tangent?
Yeah, but Rumpus, according to them, if Euclid didn't write it, it doesn't exist.
Seems so. Yeah, at least that's the Bev view. Yes. I mean, have you seen the definition of a line? Something that's it's just full of archaic language. It's just absolutely useless. Things like what it's as even as something can be, or something. I can't remember the various definitions that are just ambiguous crap.
Well, yeah. I mean, it was written 2,000 years ago.
Yeah, exactly. So you don't expect it to be good. So you don't expect it to be particularly good, but some of the language in it is a bit rough, actually. I think it's a straight line, or is it uses a phrase something as even as something can be, or things that you would not regard as being in any way useful definitions of something. So, and of course, what Bev does is, because it doesn't use maths, it's not analytical geometry, it doesn't use coordinates, it just uses basically geometry rather than anything useful you could actually use in real life to measure anything.
That's all they could use at that time was geometry, wasn't it? I think.
Yeah, that's right. They didn't really have analytical geometry. They didn't have coordinates. They did all their maths with geometry. And in fact, I think
when God spread a blanket over the world, that's basically the stuff that we're talking about. But blankets over the world, the four corners of the world.
When they had zero, they actually the idea of zero was banned in geometry because you can't have it. So they banned this idea, and also irrational numbers. They banned those as well because, of course, in geometry you can't represent. Everything is got a numerator and a divisor, and the whole point about irrational numbers, transcendental numbers, is you cannot. If you imagine a number line, going left to right across the screen, like this, this is a diagram. So if you imagine a number line doing this, and you said, well, okay, how many bits do I have to chop this up to get to this something? If you have pi here or something at this point here, and you have that, say, well, that's where pi is, matey, on my number line. And when you say, well, how far do I have to zoom in? How many bits, how many fractions do I have to chop this line up into to get the value of pi? And of course, you can't. You cannot put it on the number line. So then, if you want to represent this, they draw a strange curve or something of they do something like this to represent the break. in the number line around pi. Let me say, well, it's between that and that or something. Because that drove the Greeks absolutely potty. The fact they couldn't put pi on the number line because there's no divisor big enough, because you can prove there cannot be a divisor and a numerator combination for pi. So they couldn't put it on the number line, and so that was banned, I think, at one point as well. So yeah, all their geometrical approach to maths just caused them all sorts of problems. I think they had the concept as they didn't give it a reference. They I think, was it the Pythagoreans or something? They tried to have zero and it was banned or something. So there are all sorts of problems with using a Euclidean approach to things. You've got to get stuck into numbers and analytical geometry, which is the geometry with coordinates, maths. That's the useful stuff that we all use to do something useful, like work out the intersection where a line, the quantified form, where two lines actually do intersect, not the idea that they do intersect. We want to know where, thanks you very much. We want to know, if a graph of production of this crosses something or other of that, we want to know where that intersection is. And of course, you can't do that without putting numbers to things, and therefore you have to use maths.
Using calculus to determine the angle between two curved lines.
Yeah, exactly. I mean, this problem they've got. I mean, even you see the thing that Bev's having. The reason I just done with Bev, he said, "Oh, but it only touched right." He wanted me to draw a line, like he did not like me having these thin lines. He wanted the line, to be like
thick.
Exactly. Well, you were ahead of me there, Alan.
But by definition in Euclid, lines have no width.
Correct. But he wanted me to draw it graphically like this. And then he said, but that he wanted me to move that to that and say, there, this line here is a tangent, because he didn't like the idea that this line was sharing lots of points. Well, I've drawn this as a 1 pixel line, no matter how much you zoomed it in. He wanted it to be just touching like that. But the trouble is, when you zoom in, it's going to be a big gap. You're going to get bigger back. And if you close it up again, well, unless it's touching, it's going to go back and get gaps, going to get bigger again. And he didn't understand this. As Alan said, he's got a conflict here with a definition of a line is having zero thickness. But when he comes to do it graphically or show it on screen, he wants you to use a thick one, not understanding that for an actual tangent, it's got to share the coordinate. The tangent line has to share the coordinate. 1 point of it, infinitesimally, as Paul said, at just 1 point, infinitesimally small, but it has to share that point. It has to have the same coordinate. And of course, that upset Bev and co.
Even Euclid says it has no width.
Yeah. So, but that's why it's weird that he doesn't understand that conflict.
I just have a question from Dora that I would like to, are complex numbers irrational to Flurfs, or are irrational numbers too complex for them?
That's quite.
Absolutely, Dora.
Quite clever question, that one.
So I couldn't resist asking that one.
That's a good one. So yes, he's got a conflict. I mean, this is good. I mean, obviously, if you're an idiot, you can have all sorts of conflicts in your head without realizing they're there. But yes, there's a definition of a line that he does remember, is that it's got infinitely small thickness. But when he comes to drawing it for him on screen, which you have to do obviously to demonstrate this, he doesn't like you using infinitely thin lines.
Well, put it bluntly, Rumpus, most people comprehend this sort of stuff by about middle school. It's not that difficult to understand.
I think you're being a bit. I think you're being a little bit. Perhaps for you being a bright lad, you might be the case. But I think I'm understanding the idea. There's only 1 point, infinitesimally small, shared with a tangent, and that if you were to try and draw it, I mean, for instance, he doesn't understand when you're drawing graphically. Where is the mathematical of a line? Where is the mathematical definition? Because he doesn't like maths, of course. Remember, Bev. He only likes words and drawings, and he doesn't realize that it's in the middle of this thing, as Alan said, a thick line. But the actual line for this thick line is in the middle, so that is not touching the line. Even though it's a thick line, it's not touching the tangent. It's only when it gets to here is it touching it. And of course, that's what gets him all upset. He said, look, it's overlapping. Oh my god. I don't think Bev's ever passed any exam in maths at all. Paul's criteria for most people, yeah, but
well, I mean, a line literally can't have thickness, because that would require that not all the points are coplanar. I mean, that's literally one of the definitions of a line, that all points along the line have to be coplanar or collinear, more properly speaking.
And that is actually that's not with that language, of course, but that is actually in Euclid, because I saw it the other day, because I've never read Euclid before, because you know, I knew the geometry, because I managed to at least pass, maths O level at school and level 3 BTEC, which is A level equivalent, for getting into university. However, I don't really remember all of it, and I certainly never read Euclid. But
yeah, that's probably a fine idea.
You don't actually need to be able to use the stuff that you need to use in the real world.
Exactly, it doesn't help you at all. It's almost useless to you for actually real world stuff.
Well, we're going to watch Wally's video that he brought out on December 6th, the funeral notice, the year of the Sextants, RIP 2021, something 2021. So we'll watch that.
Okay, shall I stop sharing then?
Yep. And then if we missed out on any points, we'll after watching Wally's, and then we can finish off with a discussion there, because it is getting a bit here for me and Paul.
Yeah, I'm sure it is.
Oh, what time is it?
Oh, look who we've got joining us.
Wow.
We've got Dean popped in. He's muted at the moment. Well, he was here a minute ago. Oh, yeah, he's still here. And we've got a Ninja as well. Could you mute yourself in Discord, Ninja?
Oh no, I didn't.
No, I server muted you because you were talking.
Yeah, can you please do that? Because
yeah, I can server mute you, but next time you come in, if I'm not here, you'll have to have a mod to unmute you.
Okay.
Okay, there you go. Server muted for now. I think I've got a couple of trustworthy mods that may unmute you.
Yeah. Well, if he's still in the chat
at the appropriate moments,
we might find ourselves unmuting him.
Paul, we're trying to be polite to our say guests or visitors.
I was being polite.
Yeah.
Yeah.
Okay then. There we go. What's a P word with starts with? What's a 4-letter word starts with P, Ninja?
Can he answer? Is he muted still?
He's muted in here.
Jeez.
You're asking him a question and he can't answer because he's muted.
Yeah, exactly. We'll get Dean to answer then.
What's that?
What's a 4-letter word that starts with P?
Pratt.
Oh, jeez.
Poor Pratt. Piss.
Puss.
Prob. Prop. Pour as in I'm pouring something.
Oh hell! Press play, Terry.
I will, Blue. I'll have to.
Oh, g'day everybody. Where's Wally here? Well, today we will be ruining the whole year of the Sextant. I warned Mitchell months ago when he said that he was dropping anchor on this, that would be a fatal flaw. But would he listen to me? Well, if by blocking you mean listening, then he listened very well indeed.
You get it, Wally.
So I saw Nathan Oakley misunderstand Ruhif's most excellent adventure into the dip angle. You flatties that bang on about sextants, well, this is the downfall of the year of the Sextant.
This is why this sextant is the #1 flat earth proof, and it has not been disputed. It has not been debunked. 2021 is the year of the sextant. It may well be 2022 be the year of the sextant too. It cannot be debunked.
And this is usually the point where the flurfs just declare that you can't do trig on stars, or that we don't know what they're made of, or some other irrelevant bullshit that makes no sense. Although I guess the good thing to come out of this sextant argument is that we've finally convinced the flurfs that we can look up in the sky to work out the shape of what we're standing on. Okay, so we've just seen how the trig fails on a flat Earth, and here's how it works on a globe. As you can see, it's utterly trivial to show that the angle to Polaris matches your latitude.
This is a good one. 90 degrees right there. And obviously all the parallel rays are forming different angles there.
And it also explains why you can't see it from the southern hemisphere, because there's a whopping great big lump of planet in the way.
Yeah, there's something.
But as usual, the flurfs will just hand wave everything that doesn't suit their narrative, and just throw around buzzwords like perspective, as if it actually explains anything. So, with that in mind, I have a challenge. If this is the year of the sextant and it's the #1 flat Earth proof, then all I'm asking you to do is show two things. Number one, how do you derive the horizon dip correction if the Earth is flat? And number two, how do you derive the 1 degree per 60 nautical miles if the Earth is flat? And I guess I will not be holding my breath for genuine responses from the flurf community.
The higher our eye, the bigger the amount of the dip angle. So dip is purely a function of our height of eye. There it is right there. Dip is purely a function of our height of eye. Nothing to do with a globe, nothing to do with curvature, nothing to do with the horizon dipping away from us. No, dip is purely a function of our height of eye, right there in the reference. Dip is purely a function of the height of our eye. So if that height is known, dip can be calculated. And we've seen the table in the Nautical Almanac.
Here's your slide that they made fun of, showing the very same thing. And they're making fun of you, Mitchell. But here's a navigator on the ship, and he's got this height difference to correct, right? And how does he do that? Well, he goes to the Nautical Almanac or the AR Almanac, and he goes to corrections to be applied to marine sextant altitudes. Correction for dip of the horizon to be subtracted from sextant altitude. Subtracted always.
The horizon dip formula uses a radius pretty close to 7/6R, which kind of shows that it's being used in the real world and wasn't just pulled out of Mick West's ass.
You're actually relying on R. I bet you didn't know that. Because the dip corrections in the almanac, they are all based on R. And by R, I mean the radius of the Earth. So funny. We all knew this, but we do love to toy with you guys, and we wait to see what else we can get you to say. But you lot can't do that on a pizza platter without using R in the form of a dip correction. Want to have a dip correction for your horizon sighting? There's a hidden R in that.
Now stand aside, worthy adversary.
'Tis but a scratch.
A scratch? Your arm's off.
No, it isn't.
Well, what's that then?
See, we don't have a problem with you measuring angles. Even the housekeeping question that Nathan had to add. What was that again? Can you show how you get an angle from a curved adjacent? Well, Nathan, that does sound just a tad straw-manish, doesn't it? But of course, you don't need to just use a local horizontal plane. You could use a vertical. Well, you could also use an artificial horizon, or, as 10th Man said, how about a bobble sextant? If it's good enough for aviators, it's good enough for all of us.
Anyway, back to my point. You're on an airplane 15, 30,000 feet above the Earth. You can't see the horizon. How do you do what the mariners do on the ocean up at 30,000 feet? You have to mirror what they have. What do they have? A flat baseline. So you put spirit level into a sextant, you create that flat baseline, then you bring the sun into that center of that bubble and then say mark. Much like the sailor does when he brings the sun to the edge of the horizon, rocks it until it gets a true vertical. And they go through the next process is all the same.
At this point, we need the experts, the professionals that actually use these things. Like we're just amateurs here. We're just saying how the sextant works. We're just telling everyone how it proves the flat Earth. But we need the professionals like Wolfie who actually use this in a professional setting, in an emergency setting, when all else fails, when you've got all that technology, when all else fails, he pulls out the sextant and the sextant never fails. So at that point, we need people like Wolfie6020, people who are using the sextant, to come out and just let us know how we're using the sextant, especially at altitude. That's how I want to know. I want to know how we use the sextant at altitude. Are we looking at the horizon? Obviously, the horizon changes so much. You've got a massive dip correction. Are you accounting for the dip correction, Wolfie? Are you bringing that measurement down to the geometric flat plane? And that's where the conversation needs to go. Are we using the horizon with the sextant at altitude? And are we accounting for the dip angle? And let's go into the dip angle, Brian. I think we've been alluding to it for a bit.
Yeah, exactly. And I would like Wolfie to maybe make a video on that, because I'd like to know what it is he does with that sextant at 6 miles up in the air. Yeah. We'd all like to know.
Yeah, because what we're going to be talking about right now is the dip angle. You need to correct for the dip angle. And if you're not correcting for the dip angle, you're not getting a true reading with the sextant. I think everyone can agree on that.
So, as Mitchell says here, you have to adjust the reading back down to the surface or else it's wrong.
What we're doing when we're accounting for the dip angle is accounting for the height above sea level. Because when we account for the height, you can see that it brings the error, the dip angle error, down to the geometric plane.
Yeah,
that's the dishonest diagram that the flat earthers draw. You are not looking at the GP with the sextant. You're looking at the damned horizon. They do this consistently. The only way that sketch that he's got up there could be accurate is if you are virtually sitting underneath the damn GP, which would do you virtually no good at all. Your angle to the celestial object would be virtually straight up above your damn head.
The key question, and I hadn't seen that video of Ruhif's, and those two challenges were really excellent. Exactly what I would have done, exactly the same thing, because my challenge to them is, so what's the dip angle then on a flat Earth? And because 90% of flat earthers say that the horizon rises to your eye level. In other words, the dip angle is 0. And I got one guy about 2 months ago, it was geo or percent or something, at one point talking about the dip angle correction. And about 3 minutes previously, he said I asked him what the dip angle on a flat earth, he said it was 0. The horizon always rises to eye level. Excuse me, how can you have a dip angle and have no dip angle? And that's obviously why Ruhif asked that question. Show us what the dip angle is. I don't know, and he obviously sort of subtly there. They should normally come out with their trope. The dip angle is 0. So why have we got all these tables with dip angles then, if on the flat Earth there is no dip angle?
Yeah.
Unbelievable. But yes, I should do a video on this. But well done, Ruhif, for identifying exactly that point.
And that's why they don't want to address this, because upon correcting for the height, correcting for the dip angle, we are physically measuring with the sextant the geometric plane. It brings it down to the surface of the Earth with the flat baseline, with the 90-degree angle, and this is only achievable on a flat Earth.
Well, my mate Sean Hawkins, he decided he'd take them to task over their dip correction and why they're doing it. And as Sean pointed out, flatties don't really seem to know what they're doing and why they're doing it.
Just thinking about how 10th Man Rising claims that when you correct for dip angle, when you correct for your downward looking at the horizon, you have to move this line down to here. So you're changing this angle instead of this angle. So in actuality, you bring the line up to horizontal, which gives you your angular measurement, gives you your angle.
Good stuff, Sean. And Wolfie, seeing that flatties really don't have much of an idea of how to do celestial navigation with a sextant, decided he'd throw out one of his classic old challenges. He started at $500 for someone to show them start to finish celestial navigation with a sextant, the full process.
Emma, what do you have there?
The sextant.
The sextant? And what are you doing with it?
I'm looking at the stars.
You're looking at the stars? Well done. So I find it quite amusing to see how many flat earthers are talking about the sextant in recent weeks. They've made numerous videos and they spend hours discussing the sextant. But they're forgetting the most important part, actually using the instrument to obtain their position on the Earth. I believe that none of these flat earthers actually know how to use a sextant, and as usual, they're just talking about things they don't really understand. So in this video, I'm going to put my money where my mouth is and offer a challenge to flat earthers to prove that they actually do know how to use a sextant.
No one has taken it up yet. A few guys have chipped in a little bit of pot sweetness. I think it's up to over $4,000 now. So where are the flatties? Do they not have any confidence in their own ability either? You think this would be bread and butter for them about now? They are so confident that they can do it.
That's the knowledge I've been sharing, and now everybody else is doing. And I say, everyone, go to the sites that are available. There's hundreds, if not thousands, of videos. I've watched every one of them 10 times. All the significant navigators with navigation YouTube channels who are showing you every step of the sextant. And then it starts breaking apart when you ask the right question.
And celestial navigation have got bigger issues than this. That jolly R that flatties will never let us use at all. You're presuming the globe. Assuming R, you fundy. Are some of their favourite chants. Well, isn't it amazing where R shows up? We just saw it underpinning the whole dip correction thingy. That black swan, every time the Muppets mention how far the platform is away from the beach, they used Google Maps to measure it, didn't they? Anacapa Rock, measured on Google Earth. You know, that map that shows Earth curve if you zoom out far enough.
Why are you asking me something? So you don't have any Earth curve in your map? Don't ask me something.
I've not met a single cartographer.
Don't tell me who you've met. Just confirm you haven't got drop in your map.
Yeah, that one. There's R in that. Nautical Almanac. Based on R. What'd you say, Wally? That's right, Nautical Almanac. Based on R. So, what is actually happening when we do celestial navigation? We measure an elevation angle to the celestial object. That's simple enough. So simple, even a flurf can do it. But what we really want is the angle from vertical anyway. So measuring the vertical is actually better. Here, let me explain why. What are we really doing when we use the sextant for celestial navigation? Let's try this simple thought experiment. The navigational star of interest is right overhead. Okay, 90-degree elevation. Where's the GP? 0 degrees difference from the sight to the star to our zenith, so the GP is right under our feet. Now wait 4 minutes, do the sighting again. You will find that the star has moved exactly 1 degree. Now the almanac gives you the distance or the range of 60 nautical miles. Wait another 56 minutes or 1 hour from when the star was directly overhead. Now the star is 15 degrees from our zenith.
A 15-degree per hour drift.
Thanks, Bob. So now the almanac gives you the distance or the range of 900 nautical miles. So just look it up, mate.
Way that we get the D, it is in the nautical almanac. Yeah, if you're getting a 30-degree angle to a known navigational star, you just look it up in the nautical almanac, and you know how far you are from that GP. We're not doing calculations here. It's already in the book, mate. Yeah, you can do calculations. You can get that distance using a calculation, but...
Now, you said you can do those calculations. Have you ever looked at how and why they are done? Seems Mitchell, or rather 10th Man, if he has actually ever done a full sextant celestial navigation from start to finish, they get to step 2 and then they cheat. They get an angle via the nautical almanac and voila, they have a distance to the GP. Now this is where it gets interesting. Those figures in the nautical almanac, they are converting the angle to a distance. So then you can go on and complete step 3, the trilateration step. So it seems to me that flatties are treating the almanac a bit like the Book of Spells. They say the magic words, "O great almanac, wise art thou, we look upon thy great star Alpha Canis Majoris at the very hour of 2021, November the 21st at 1720 UTC, and we saw a corrected sextant elevation of 34 degrees and 21.9 minutes. Please reduce unto us the distance of the GP that pleases thee, Allow us to rinse and repeat this thrice. The number of the sightings shall be 3. 2 sightings we shall not take unless we proceed directly to 3. 4 sightings is right out. Where are our intersections of possible positions? Oh, mighty circles of equal elevation. Well, I just pop all that data into a website. It does it for me. And it shows 944 nautical miles. So that got me thinking, how does the angle of the star become a distance on the surface? Then I saw this.
At any given moment, every celestial body may be mapped to the Earth, as there is one point in the terrestrial sphere where the celestial body lies directly overhead. This is called the celestial body's geographic position, or GP. If you were standing at the geographic position, the celestial body would be directly overhead, known as the zenith. Measured from any point on the horizon, the angle of this celestial body would be 90 degrees. Astronavigation allows for determining your geographic position by measuring the angle from the local horizon to the celestial body and determining a line of position, which is actually a circle on the terrestrial sphere. Locally, however, these circles can be treated as straight lines. By obtaining a line of position for 2 or more celestial bodies, these lines should intersect to mark your position. This process involves knowing the geographic position of the celestial body at a given time and solving some spherical trigonometry. By using publications produced by the US Navy and their UK partners, spherical trig calculations are replaced by tables, and this process is greatly simplified. Only addition and subtraction are needed to complete a sight reduction form and obtain a line of position.
Oh, so the almanac is to simplify spherical maths to just additions, subtractions, and finally a multiply by 1 nautical mile per minute of angular separation. Well, that seems super easy. Barely an inconvenience. Seems to me that the almanac is a globe tool. Well, that's interesting. Let's see if that's true. So, step 2, the nautical almanac. I downloaded code that prints the almanac for any year that you wish. And here is the code for that cool website doing the sight reductions. So let's have a look at that. Oh, look, global variables are plenty. And what's this one here? Radius. Oh, that looks like a very familiar kilometre value to me. So now we see that the nautical almanac, made by astronomers, as Mitchell says, it's full of R-holes that preclude any flatty using it.
It's because this book is made by astronomers, the almanac. We're talking about the almanac. This book is made by astronomers. And as astronomers don't talk about latitudes and longitudes, they do talk about hours and angles.
Well, hello, Mitchell. How are you? So I hear that you fancy yourself as an expert in navigation using a sextant. Well, you see, Mitchell, there is this little thing called latitude, created by Hipparchus in 190 BC. And just quietly, it's based on a sphere, Mitchell. And then, Mitchell, there's that staple of globe-based navigation, namely 69 statute miles per degree of latitude. That is the pole-to-pole distance of 12,436.8 miles divided by 180 degrees. And that equals 69 statute miles per degree of latitude. It's not a coincidence, Mitchell. So sorry, Mitchell, but you are going to need a globe for that.
So it seems now that we've taken away the nautical almanac from the flat earth, because it's full of R's, they're left without a leg to stand on, as they would just be resting.
Say goodnight. 2 is the age of the sextant.
What are you guys going to do now? Seems celestial navigation, the year of the sextant, didn't even make it to its first birthday. Oh, how sad is that? So unless flat earthers can figure out a way to do the trigonometry correctly that works on a flat earth, and they're going to need a model for that, I guess you're not going to be able to play with sextants anymore.
Hey Mitchell, you want to do celestial navigation with a sextant? You're going to need a globe for that.
In summary, you guys are going to have to be so careful from here on in, because actually we live on a globe. There are R-holes everywhere and they're embedded in everything you do, and it's not always apparent, and you guys really aren't smart enough to figure it out. Truth be told, you don't really care, do you? You'll do whatever it takes to get the answer that's flat. Even when we demolished your chant rant, you guys still carry on as if nothing ever happened. You don't know when you beat.
Yeah, that can't be right. That can't be Australia. Australia doesn't exist.
I've got a small view of that. I can't see it very well on my screen.
Yeah, I don't think there's anything beyond this.
Good video from Wally. Does good work. That's a good combination
done
of
well on
facts
that
and presentation. That's a good one.
Now I know I'm going to ask questions like I normally do, which I like to. The GP that they're mentioning the few times I've been hearing it, is that something that's calculated or it's known or?
Well, you can calculate it, but if you wanted to know, for instance, if you wanted to know where, I don't know, the Southern Cross, for instance, it was relevant to you, where would you have to be on the Earth for that to be overhead? And it's going to depend on the time and where on your latitude and your longitude. But there is a position if you wanted to say, obviously there's some places it can't be overhead, but I think probably actually might be. Yes, actually that might be. Okay, I'll take that back. You might not. You do, yes, you won't. Yeah, you can't pick on a position necessarily and know the two. But the point is, there is a place on the Earth where the Southern Cross is overhead at this moment, and from the Nautical Almanac, it can tell you where that is now, this second.
Right.
And if you then make an observation of it, and you work out the angle to it, you then know from its angle above the horizon. Well, actually, you have to convert. There's quite a complicated calculation, which indeed I've just been trying to do recently, actually, where what's called the altitude that we've been talking about of the angle to the horizon. The Southern Cross has what's called a position on the celestial sphere, and that has a declination, which is its the equivalent of its latitude, and its right ascension, which is equivalent of its longitude. And so that's fixed, and that obviously moves as with the Earth rotates. So then you then from the nautical almanac know where the GP of a star is, where on the Earth it's overhead. And then if you then use your sextant to work out the angle to it, you then simply multiply the number of degrees. Once you've done there's some calculation you have to do to get these bits and bobs as well. But fundamentally, once you know where that should be and you know the angle to it, then you just simply say, right, okay, multiply that angle by 60 nautical miles, and you then know that you're 60 nautical miles from that. But as they said, it's on a circle around it, so you then have to use 3 other ones to then determine your actual position. But the point is, there's somewhere on the Earth that has Southern Cross at its zenith right now, and that's in the almanac. And so if you then measure the angle to, you then know your respective position, how many miles away you are from that GP.
Right.
If that's clear, I don't know if I may have perhaps.
All these little bits of information I'll take in, and it'll add up eventually.
So it's just fantastic, and of course that's the other thing that was fantastic in there. That I say, look, I haven't seen that video of Ruhif's. That how do they come to the determination that 1 degree is equal to 60 miles? And you'll see them doing this all the time in the Nathan Oakley, whatever. They multiply these angles by 60.
15.
Sorry.
Multiplied by 60 nautical miles. Well, where'd you get that from? And as Ruhif challenged them there, that doesn't work on a flat Earth. As I was showing in my graph that you saw, that's what one of the curves I drew for the flat Earth was. It varies depending on where you are. The angle to Polaris changes how many miles you have to go to change it by 1 degree. But on the spherical Earth, it doesn't. It's entirely constant everywhere. So that calculation is entirely globe dependent. So whenever they say, oh, you multiply the angles by 60 nautical miles or 69 statute miles, you can talk to them, well, you need a globe for that. You need an R for that. and of course originally sextants were not used to do this trilateration of the to get your position. They could only give you your latitude, because what they used it on the sun or Polaris or something. Because what you need to know, of course, for the to do that is the time of day, your time in terms of GMT, because of course these stars are busy rotating like crazy and they're moving around the sky. So you need to know, the almanac needs to know where they are for a particular time. And if you don't have a particular time, if you don't know what the time is relative to GMT, you're stuffed. And of course, there was no way of knowing that until along came chronometers and John Harrison, and even he didn't really perfect it. And even at the time of the Napoleonic Wars, with the British Navy, when we were fighting Napoleon, only a couple of ships had timepieces on them, so that they actually knew what the time in GMT was to be able to do these sorts of things. And it took how many decades to come up with a clock that would work on a boat, a rolling boat. So it wasn't until that point that you could do these tricks with 3 stars. The only thing you could use a sextant for was to determine your latitude. You couldn't use it to determine your position because you didn't know what the time of day was relative to GMT. So it's quite impressive. Yes, I've been playing around with the law of cosines on a spherical body to work out the conversion between what you measure as, because if you imagine the screen you were showing earlier, in fact your avatar now, it's not showing you, all the stars there are busy rotating and moving around and actually converting their celestial coordinates on the celestial sphere into an altitude, i.e. what the sextant should be reading, requires quite a lot of calculation. But as you say, that form that guy was filling in, or whatever it was, we saw briefly, which I didn't know this existed actually, gives you a procedure to do that. But it's actually, the maths of it is moderately complicated.
That's why the Royal Navy are so very kind to calculate it all out for us and publish it.
Yes, they are very kind. Yeah, that's the thing, Alan. That they is there some British standard for providing a nautical almanac, or have the Americans taken over it or something?
I have absolutely no idea because I'm not a sailor.
Right. Okay.
And honestly, I hate small boats even more, so I don't go out on the water at all.
Right. Okay. But you were in the Navy, though, weren't you?
No, I wasn't in the bloody Navy.
Oh, sorry. Sorry. Apologies.
I was in the bloody Royal Air Force.
Sorry, I thought you did something with radar on boats at one point.
No, I've talked to flirfs about radars on boats because that's really the only time they come into contact with radar systems. But I much prefer big ones that look for aeroplanes high up in the sky.
Right. Okay. Sorry. For some reason, I thought you also did something with radars on boats. Okay.
Yeah, I've talked to idiots about them.
Right. Okay. That's where I must have got that impression from.
No, they're definitely not Wavy Navy.
Right. Yes, because they did mention in that video that he had there that there's an American publication that, with help from the British thing, I would have thought we'd had a history of doing we must have had a history of doing our own thing, providing, because we obviously have the biggest navy. I mean, everything revolves around British, GMT, all the maps revolve around that. I would be surprised if there was an American standard that the nautical almanac wasn't a British thing. But anyway, okay. So.
Yeah, I'm sure these days it's a joint publication.
I'm sure, yeah, that must be what it is. Yeah, I mean, it's some international body or something.
And I like how radar proves the globe and not flat Earth.
Always.
Well, everything proves the globe, doesn't it? I mean, even just looking out and looking at a sunset proves the globe. It's just everything you do. I mean, they talk about Nathan Oakley keeps on saying it's observably flat. No, it's observably curved. And we see the fact that stars move around 15 degrees per hour. We see that the things go over the horizon. We see sunsets. Everything you have a look at, just because the Earth is big, okay, so the effects of curvature are small, but there are lots of ways it manifests itself in a readily understandable way.
Yeah. What gets my goat is every time I hear bloody Lemonbird bring up perspective in the hallway. We're talking about one thing to do with about ships going over a horizon or whatever, and then straight away he brings up Oh, but in a hallway, in perspective.
The lemon.
Oh, yeah, lemon.
Lemon's got a hallway fetish.
Yeah, he's got it. He definitely does.
Yeah. Of course, it doesn't help that Rakia, it seems, now has access to a radar on a small boat that has over-the-horizon facilities. Because because it uses ground wave propagation, but it seems to be really hard to find out actual technical details on it because, company secrets.
Right.
But
how much further over the horizon does it go?
Apparently, you can get like oil rig sized returns at 72 nautical miles
from a height of
20 feet because it's over the that's the point. It's over the horizon, so it's,
I was just wondering how much over the horizon it was.
It's
is it doubling your visibility or
at least?
Right. That's pretty good.
If you've got a large enough target.
Yeah.
Right.
I suspect they're doing some fairly tricky stuff.
Yeah, I mean it's
that ground
just
wave.
over
Ground wave's not going to work very well above about 4 megahertz. Reliably.
Why is that?
Yeah.
Well,
physics.
I know. I just wondered what the physics were. Sorry, I'm pressing on that blue. Sorry to probe you.
Yeah, we could get into a 2-hour discussion about that, but it's enough to know that ground wave propagation is limited and becomes more and more limited as you increase in frequency.
Right.
And typically, ground wave propagation is thought of to be, stuff you're using below 3 or 4 megahertz, something like that.
Right.
But even though they're using X-band radar, you can still simulate a 3 megahertz radio signal if you want to.
Right.
You can modulate that
right.
X-band signal.
Right.
And effectively create your own low frequency sideband.
Right.
And that's I suspect that's what they're doing. But what do I know? I'm just an old double E.
Well, you seem to know what about your when ground effect is possible. Yes.
Yeah. Well, I remember. I mean, 72 nautical miles is 1 degree, and I can't. Sorry, I'm not going to work out the. But you've got 12.
Well, I can tell you what the visibility of 20 feet. So if you want to know whether something is, I can do the calculations on telling you what's visible. So if you had
it's not going to be optically visible.
No.
Even an oil rig is not going to be optically visible at that distance. But yeah, it's not like that. It's impossible to do it. It's because remember, and we were talking about this when Terry was doing a history of technology talks that we did earlier. Marconi used ground wave propagation to send his first radio telegraphy signals across the Atlantic.
Right.
Yeah, he was only operating at a couple of 100 kilohertz, I think.
Yeah, something like that.
Because it works very consistently in those low frequency ranges.
Now, you can't send data very quickly because the bandwidth is incredibly limited.
Yeah, you don't have a lot of bandwidth, that's for sure.
But that wasn't so much of a problem for Marconi because he was using. I think he was still using spark transmitters, wasn't he?
Yes, I don't think he ever got round off sparks, did he? I think he was. Yeah.
And of course they're wide band, but you're not going to be keying your morse that quickly.
So presume that happens unconsciously. So when you do this ground effect you're talking about, if I just simply broadcast a radio signal, say 20 feet off the ground, I'm automatically going to get a ground effect. Just as a matter of if I use the right frequency. I don't have to do anything special to get this ground effect.
You get different modes of propagation, essentially depending on the wavelengths, and also, of course, it depends on your aerial configuration as well, how well it'll work.
Right.
It works much better if you use vertical polarization, so that the E field is working vertically.
Right.
Yeah.
Right.
Because obviously we're way down in frequencies where we're where we're considering it as waves. That, it's waves. There's nothing but waves.
Yeah.
And so you would want a long vertically mounted aerial to do it.
Right.
Which is highly impractical for very low frequencies.
Yeah. Well, you can hoist it up on a balloon, Blue.
Oh yeah, you can do that, but you got to do something like that.
Yeah.
But what? Because the length of the aerials.
Yeah. Well,
you need a long aerial.
At 4 megahertz, you're looking at an 80-meter wavelength.
Right. And what fraction do you need of the wavelength do you need to do it for your antenna? Half of that or something?
Well,
quarter of that.
Quarter of that, possibly.
Yeah. Right. Half or quarter is usual.
Half wavelength is normal.
Right. So you're saying you need a 40-meter pole, vertical pole, to get the right.
Well, yeah, vertical wire.
Or vertical wire, yes.
Yeah.
God, I really ought to learn more about radio. It annoys me I don't know enough about this sidebands and stuff and God knows what else. Something I really feel I should know. I know you've done all this, Blue, and obviously Alan knows all this stuff. I think I'll just train myself to go and learn about radio a bit and become a radio ham for a bit.
Rumpus, we can't know everything there is to know anymore. There's just too much stuff.
There is too much, yes. But something I feel I should know. Something radio seems to be something
It's why we need experts in various different fields.
Indeed, specialisation. I know, but I think it's something I should have done it in my past. I should have been interested in radio and played around with it a bit more. I mean, I did enough some sort of the theory of it at university, but I've just never did practical with it. But yes, I feel it's something I should know about.
Yeah, those low frequency ranges. You're an amateur radio operator trying to operate on 80 meters. Typically, you're going to use just a straight dipole antenna, half-wave dipole. A possible other configuration is what's called an inverted V, where you simply elevate the center of it, make it look like a V upside down. Those work pretty effectively, and they start to approach the performance of a vertical.
Right, and so if I want to have a small little radar thingy on this boat that Rakia's got, obviously I can't have a 40-meter pole on that. But you're saying using sort of sideband tricks, you can effectively pretend that you're operating at 8 megahertz.
Just through normal sampling theory. If you've got you can simulate any frequency you like as long as you start with double that frequency.
Yeah. Right.
Right.
Yep.
So if you've got gigahertz transmission capability and you modulate that at say 3 megahertz, it looks like a 3 megahertz radio signal.
Yeah. Right. Yes, I suppose a bit basic modulation stuff.
Yes, and it will behave that way.
Right.
At least like I said, that's my guess at what they're doing.
But the orientation of the E field that Dan was talking about, is that possible to do with without having a tall thing?
Yeah. You can have you can have all you can have any or all of the polarization options.
Oh right.
I mean, because you can have vertical polarization, horizontal polarization, and you can even have circular polarization where you rotate the E field.
Right. It's just that you said earlier, you said that you needed a vertical pole alignment of your wire to get this E field, and now you're saying you don't.
No.
Right, go ahead, Alan.
It depends. A lot of it depends on your antenna configuration. If you are just transmitting at 4 megahertz, you're going to want a big, long vertical aerial.
Right.
But when we're using X-band radar, which is 6 gigs, I think, ish. So that's 6 gigahertz.
Yep.
You can use really small aerials that are basically lots of small little elements together.
Yep.
And you can do all sorts of beam forming and beam steering stuff with it. And yeah, you can get it to choose your polarization.
Right. So providing you're doing some sort of starting off with a high frequency and then sampling it down to the low frequency, obviously you can orientate your starting thing as any way you like.
Let's just say modern antenna systems are a complete and utter art of their own.
Right.
With a little bit of magic thrown in sometimes.
Right, so obviously when it's something small, you can obviously, if you've got your small thing, obviously you can do whatever you like with the polarization, but then it was just the issue was how would you get down to having an efficient 8 megahertz transmission, and Blue was just basically saying you can do that by modulating your original high frequency signal. Right?
Yeah.
I think okay. So,
you
get the polarization just from your setup, and then you just around the way you want it, and then the modulation obviously is not in any particular direction. It's just modulating whatever signal's coming out of that, and then that gives you your 8 megahertz from your thing, right? Okay.
Yeah, it's called being clever, and the thing is that the website really doesn't go into details because, they've spent $10 million they've spent $10 million designing this stuff. They don't necessarily want to let
yeah, I mean, I can understand if you think, I mean, if suddenly your radar on your little boat can suddenly go twice as far as it did before, obviously that's a huge competitive advantage against other radar systems, isn't it? If it doesn't cost much more, you suddenly you can suddenly see twice as far.
I have a feeling, because I had a quick look at their website yesterday, the manufacturers, and of course it dropped me on the UK page because it detected where I am. And I believe the top of the range system is only about £2,500.
Right.
I was kind of surprised how cheap it was.
Yeah. Right. And for that you can see 70 miles odd. Okay, great.
Yeah.
Of a big thing.
Obviously, you may well need to pay for some upgrades. That's probably the base price.
Right.
But
can you see that tower that I'm sharing at the moment?
Yeah, I can. Yes. What the hell's that?
That's the Woodside, or it used to be. It's been demolished now. That was the Woodside VLF navigation tower in Gippsland here in Victoria. That's the sort of thing they'd use to send out a VLF radio signal for navigation purposes. 425 metres high.
Wow.
Yeah. That gives you the idea of the size of the tower they need for those low frequency communications.
Yeah.
What would be the range
What's
for that?
VLF?
For
very low frequency, I presume that stands
very
for.
Low frequency. That worked at 12 kilohertz, if I remember correctly. I think it was 4 and 12 kilohertz that worked at.
I don't know. Yeah.
Wow.
I've looked. I actually looked. Oh my God! They only needed 4 of those worldwide to give you a worldwide navigation system.
Yeah.
Yeah.
I mean, they binned it the minute GPS came along, because GPS took you from a couple of nautical miles to
meters.
Yeah, less. And if you were the military, because that was a military thing really. If you were the military, GPS to start with was the less than a meter.
Yeah.
Or,
they made it worse for public use. Absolutely. Yeah.
Yes, because initially they encrypted the bottom bit of the signal so that you couldn't get. I think it restricted civilian stuff down to about 10-15 meters.
Yeah.
But one issue of when they decrypted it was that now there's a variable offset from what you got under the old system, which makes going back to locations difficult. Because you've got this location that you did in the GPS, and because they've changed the accuracy thing, it actually reads slightly different, and you can be, 10, 12. You can be up to tens of meters off the location that you're trying to find that you previously marked with GPS.
There was an American system, wasn't there, for like GPS that was again based on some transmitter thing. I think I've talked about this with George. Was with one system that I don't think it was this Omega thing. Was that?
Well, there was radio navigation systems that weren't German. You had G, which we invented, and it went into civilian use as LORAN, and then LORAN went through about 3 or 4 iterations, and then the
sorry, I was just looking at what.
Yeah, well, that's what happens when you stop maintaining it.
Yeah, well, I presume that was demolished. I presume that was part of it being demolished.
That was a planned demolishment. Yeah.
Okay. Oh yeah, I see the puffs of smoke from the explosions of the stays now.
Yeah.
So you went through several variations of LORAN, and then Omega, and they all basically used the same type of system to get the position. And then there's also Decker, but Decker's really only short range around the coastal areas, and that uses a slightly different method for doing the location. And I'm sorry, but I can't remember the correct words, and I really don't fancy flicking through my notebook.
That's okay. That's lots of information there. Thanks.
So they were all ground-based systems.
Yeah.
That allowed ships and aircraft mostly, I think, used LORAN, and the Decker was mostly for shipping because it was just coastal. Whereas LORAN will cover. LORAN will cover over land as well.
And Omega could be used by both ships and aeroplanes.
Yeah, I mean, again, it's the sort of thing when you're doing a trans-Pacific crossing. It's handy to and you can't get a sight because the weather in the Pacific can be a bit crap, can't it? It's nice to know your position. I mean, even if Omega can only give you a position to 10 or 12 nautical miles, that's better than dead. That can be better than dead reckoning.
Yeah.
And of course, as you get close to your destination, you'll then be able to pick up LORAN again, or Decker, or whichever system you prefer to use, which will give you very accurate positioning around the coast where you kind of need it.
So that Omega, you said that only needed 4 of them to cover, and also was that using ground effect as well? Then
that's why it's at 12. That's why it's at 12,000 hertz, not 12 million hertz.
Yeah. Right, so that's specifically for that. Okay, so to get the ground effect.
Yeah.
Right,
I think this conversation to do with radar would have took a whole new stream to have gone through all this.
Sorry, Terry.
Yeah, that's okay.
Fantastic stuff, Alan. That's very.
We aren't even talking about. Well, we're not talking even about radar now.
No, so that's fantastic, Alan. Really interesting. And right, I mean, I was aware of ground effect. I didn't realise it was that amazing that you only needed 4 stations in the whole world using ground effect to give you at least a semi-decent idea of where you were. That's amazing. That is amazing. God.
Yeah. It'll get you close enough to know. It'll get you close enough to your destination to then be
so you can see it.
Other stuff. Yeah, I mean, I wouldn't trust it up close to land, or like with the admiral who ran his whole fleet onto the Scilly Islands.
Oh God.
Because he was somewhat out by his longitude, because no chronometers.
Yep.
Well, I've said me goodbyes out in the peanuts. So.
Okay.
Well, thanks, Alan. Oh, John, we couldn't get a word in sideways. John wouldn't shut up. Thanks, George.
Yeah, sorry about that.
Thanks, Blue. Thanks, Rumpus. I welcome you to come back any time if you want. You know where
Thanks
we
so
are.
much. Thank you.
Dean, he did get 2 words out, or 3.
Terry, I got all the words with 4 letters and starting with P. I'm still going in my own head.
Yeah, but there's only one word that is used here. Dora, Carl, Dart, Anamorphic. Who else we had out there? Thurston, Biggest, Doggers. Who have I missed?
There was a Mum's Bakes Cakes I remember being mentioned.
Mum Bakes Cakes, RT96.
Oh, he's around here, is he, as well? Okay.
Who else? Room Fondle.
Oh, he's good.
I've got
you got a good selection of people, then, haven't you?
I've got to keep scrolling up. Yeah, Professor Phil was there earlier. I think Wally might have dropped in to say good day, drive by. Jaren Neurism. Fred Bailey. Peter G. Jinx Yu. Clive Wells. Got to keep going up here.
Who's there? Was he? Right, bloody hell.
Yeah, who else is out there? Yeah, I'll get a few.
Peanuts are very elite.
Yeah.
Peanuts are...
I said Dart, didn't I? We did have Gary earlier. Gary comes in and says g'day. I can't go any further. If you're out there listening, it's your last chance to get a shout. Carl, don't forget Carl. Don't forget Carl.
303DB.
Oh yes, they'd been subbed to me for a while and didn't get a spanner. Maybe they did get a spanner at the beginning, because remember I did the culling there one time accidentally and everybody lost their spanner. I accidentally clicked the wrong thing and I thought, oh shit, now I've got to go and do it all over again. So, no, he wasn't a newcomer, Dora. He'd been...
No, he's never spoken. He's never ever spoken before, so he won't have had ever have had a spanner.
Yeah. All right then. Well, good night, panel. Good night, Peanut. See you on Saturday. Well, I'll call this stream. What did I renamed it. I don't know if the grammatically I could be wrong, but I just wrote the sextant equals globe. I didn't know if it'd be the sextant equates to a globe or the sextant equals a globe. Equals globe. I don't know. I just thought I'd write that down. And then I put full stop in the end, as in the word full stop.
Yeah.
There we go.
Okay. If you're going to use equate, you have to use equates too.
Yeah. It would sound better to equates to, wouldn't it? The sextant equals globe. Anyway. That'll do. Oh, Judy Bassett has been here from the start too. Oh, okay, Judy. Yeah. Oh, Stevie B. See, we've got a couple of the late comers to put their shout outs to. Righto, I'm gone. Say good night.
Good night, Peanuts.
Bye, Peanuts.